and you don't
Okay.
have to write it because that is inbuilt in the platform. Right? From your perspective, you won't be doing anything from the algorithm perspective.
No, but if I'm developing my own blockchain, in that case, I have to choose the algorithm, and I need to understand which algorithm will work. And
I will give you an understanding of what the algorithms are. When you develop your own blockchain, you're not going to write something from scratch unless you
okay.
plan to do that and release a new blockchain on the ecosystem.
Okay. Okay,
There's a
that's
lot of
fine. So
noise.
when
Hello.
There's a lot of
Hello.
noise. Can others go on mute,
Yeah.
please? Only those who... Yeah. So I was saying you're never going to create a blockchain from the scratch. Okay. You're going to
okay.
take the code available on their respective sites. So for example, Bitcoin, you can get it from bitcoin.org. For Ethereum, you can
Okay.
get it from Ethereum site. So the platform is available freely. The application that you want to make out of it, so you have to write the application code, not the platform code.
Right.
You're not going to
Okay.
change the proof of stake or proof of work algorithms because that comes as part of the package. Unless you come up with something that's better than these algorithms, okay, and you create a blockchain of your own, so which is doable.
Yeah.
But
So
then it is not an
even in the
existing algorithm.
So even if we need to choose the platform, so which platform I need to choose? I need to choose the Bitcoin versus Ethereum versus Ripple.
So that we will have. That we will have.
Okay, got it. Yeah. So you will cover both, like what are the specific feature, why we should choose this versus that, right? Those kind of things you are going to cover, right?
Yes.
Okay, got it. Yeah, no problem. Yeah, we can go ahead.
Hello.
Yep.
Hey, this is Vinay. Sorry, I was a little late.
No problem, Vinay. You've got a question?
No, I just wanted to say hello to you and all the others. Just to let
Okay. Okay, no problem. So I guess we are good to start then.
Yeah.
Okay.
Hello, Vinay.
Hey, Abhishek.
Yeah, this is Ashok here.
Hey, Ashok. Hi, Ashok.
Yeah.
Good evening.
Yeah, hi. Yeah, good morning. So, let's get started.
Yeah, sure.
Yeah.
Can you make me the presenter? I'm unable to share the screen.
Do you see an icon of a computer in the my computer and video?
Yeah.
If you click, it should. I made you an organizer.
Okay. Now I'm able to. So can you guys see my screen now?
Probably loading. Not yet.
Okay.
In the status, it is showing that we are viewing your screen, but it is not loading.
You might want to unshare, share again. Hello, Sunil. Are you there? Yeah, sure. Can you check on Sunil? Looks like it shows offline in GoToMeeting for him.
Today the sound quality is looking a lot better than yesterday.
Yeah. Actually, we have changed the headphone. The problem
Oh,
was with
okay.
the headphone. Yeah. It was
Oh,
Bluetooth.
I see.
Yeah.
Oh, I
Wireless
see.
headphone was
Hi all,
making
I'm back. Got disconnected. So please make the presenter now.
Yeah, Shida, can you make him presenter?
Hello.
Yeah, Sunil,
Yeah.
did you get
Sorry.
any pop-up?
Yeah. I got it. I'm just clicking on it.
Mm-hmm.
There was so much silence. I thought maybe I got disconnected again.
Actually, I was waiting for Sridhar. Then I thought
Okay.
to make a presenter. Yeah.
Okay. Is the screen visible now?
Yeah.
Okay.
Yeah, you can see it.
Okay.
Yeah, I'm
So
able
we'll
to see.
start.
Yeah.
Perfect. So we'll start now. Okay. So yesterday we saw these topics: the history, why blockchain, the evolution, the open issues, and some of the success stories. Today we'll be covering cryptocurrency and blockchain. What is cryptography, what is cryptocurrency, what is anonymity and pseudo anonymity in blockchain, what are digital signatures, what are hash codes, what are hash pointers and data structures, how you can view the blockchain transactions on the web, what are distributed networks, and then we'll see a comparison of blockchain versus databases, when you should choose a blockchain or when you should choose a database in your particular application or at your particular projects. We'll see the key terms that people use in the blockchain world, so you have an introduction to this when you're speaking to people in the blockchain arena. You can understand what they speak and you are able to use the right words. We'll see the distinction between databases and blockchain. We'll see what a distributed ledger is. We'll see what makes up the blockchain ecosystem. Hello.
Yes, Sunil, I'm able to hear
Okay.
you.
Okay. No, I got. It was a strange message. I got a message saying Sunil Pandey has left.
Oh, okay.
Okay. And then at the end, we'll see the blockchain structure. So the key components that make up the blockchain ecosystem. Okay. And we'll see the permissioned and permissionless blockchain. So the algorithm stuff that you're talking about, when to choose what, we'll see as part of this. Okay. So, okay. Before we start, I would like to know from you all what is your understanding of what cryptocurrency is. So anyone would like to go ahead and answer that?
Sunil, so this is when I'll start.
Yeah, Vinay.
So my understanding of cryptocurrency is like it's a virtual currency.
Mm-hmm.
So which means like it happens to be in the digital form, and
Yes.
it's not a physical currency, because we are used to, when we say currency we immediately think about notes and coins. So this is not notes and coins, but it is in some form of digital form, which cannot be physically felt basically. So this is my understanding of cryptocurrency.
Yeah. So you are almost there. So yesterday we were discussing this. Talked about one major problem that the initial digital currencies had. Anyone remembers what the problem was?
So some
Initially,
third
yeah.
party has to validate it, right? So that was, I think, one of the major problems. Like bank has to
Yeah,
validate.
that is problem with the ecosystem. Specifically with digital currencies, we had a problem called double spending.
Yeah,
Yeah.
double spending.
Right?
Yeah.
So one of you had asked what double spending is. So we'll first see what double spending is. Uh, Simply speaking, double spending is being able to spend the same money twice, right? So you have a $10 bill in your pocket. You go to Starbucks, you order a coffee, you give the teller your $10. Okay. Now there is no way you can spend the same $10 at a barista, right? Because that $10 has been spent unless you beat up the teller and take the money back. So in physical currency or in physical world, that is not possible. But what is digital currency? Digital currency is just another file on your machine, right? Now, as we saw, or as it is possible for any other file on your machine, you can send it to as many people as you like, right? So with digital currency, there was always the underlying problem of double spending. A lot of algorithms were tried, but none of them successfully resolved the double spending problem. Okay, and that is why the initial we saw the evolution in history yesterday, right? David Chaum, Wei Dai, and these guys tried a lot of options, but all of it never succeeded because of this problem. So what double spending is, right? So say we've got Alice, we've got Dave, and we've got Bob. Alice has got a digital currency, say BTC 12345, and Dave and Bob are two e-commerce sellers on the internet. Now for them to be selling products, they've got their website set up, they have got a cart, everything is there, right? When Alice chooses a product, okay, she has to show that she's got that amount of money to purchase it, right? So what the sellers will do is just verify whether she's got the money or not. Okay. Now, if Alice initiates a transaction at the same time with both the parties, okay, Alice would be able to do the transaction. Okay. So that is the double spending problem. Okay. So in blockchain, okay, like we talked yesterday, you have a lot of transactions that happen in a particular duration. All those transactions are pushed to the network. Okay. Someone will take all these uncommitted transactions, make a block out of it. Then they run certain algorithms on it. Okay. And once the algorithm has been successful, we'll see what that algorithm is. Once that algorithm has been successful, the block would be successfully placed on the network. So when the block is successfully placed on the network, it is broadcasted to everyone who's there on the network. Okay, that marks the confirmation that the transaction has taken place. Now, in case of Alice, okay, say Alice spent the same coin. Okay, initiated transaction, send the same coin to Dave and send the same coin to Bob, right? So say there were a lot of miners in the network. Okay, they picked the transaction B1A. Okay, in which Alice had sent the money to Dave, right? And there are other pool of miners who picked the transaction B1B, in which Alice is supposedly sent the money to seller 2, which is Bob. Okay. Now, once B1B block is confirmed on the blockchain, okay, the next block will always have a reference to the previous block. So if B2A is to be created, it has to point a reference to B1A. So remember, in data structures, we had something called as linked lists, correct?
Yeah.
So in a linked list, there's always a pointer to the next
Previous next
date.
node.
Yeah, correct. So similarly, here you have a pointer to the next and a pointer to the previous one. Okay. So after B1, you would have B2, B3, B4, B5, B6. Now in the Bitcoin blockchain, these blocks are created at a difference of 10 minutes. That is pre-decided in the network, right? So once a transaction has taken place, after 10 minutes, that transaction gets relayed on the network for everyone. Okay. That is the time it takes to prepare a block, do all the validations and confirm the transaction. After 60 minutes, okay, which is 6 blocks. So if a transaction has been created and there have been 5 blocks after it, that is irreversible, right? That transaction is considered to be the ultimate truth or the ultimate transaction that has taken place, right? So in this case, if the same transactions, I mean, Alice had spent the same money with Dave and Bob, okay, in this case, Bob would be the guy who would be losing, the money, because he is not really got paid. Alice tried double spending it, right? That is why we have this concept of confirmations, okay, in blockchain. So unless there has been a confirmation of your transaction, you're not supposed to believe that the transaction has really taken place, right? So that is why when we were talking yesterday, I said one of the major challenges that blockchain implementation face vis-a-vis Mastercard or Visa is it takes a lot of time to confirm the transactions compared to Visa or Mastercard, where it is instantaneous, right? You swipe the card, you get an SMS right away that this much amount has been debited from your card. So that is the challenge that the current blockchain implementations are working with. Ethereum says it is 14 seconds for them. Still, 14 seconds is a lot of wait time. Okay, you cannot be waiting 14 seconds for a transaction to to be confirmed. On Bitcoin blockchain, they say if it is a large transaction, you should ideally wait 1 hour before you ship the goods. If it is an e-commerce transaction, the point being, if there have been 5 successful blocks after your transaction, the block containing your transaction, there has been a lot of computing power that has been spent for someone to be able to do a fraud, right? For B1B to get into the network, they would require a huge amount of processing power to invalidate all these transactions, which is not possible, has not been possible till date, right? That is why they say 10 minutes for confirmations and at least 1 hour to be deadly sure that this transaction has taken place.
Sunil,
Okay.
one question. You did
Yes.
mention yesterday, and based on my understanding, that once the transaction has happened in blockchain, it cannot be reversed.
That's
Then
true.
why we need to wait for the sixth transaction?
See, your transaction does not automatically happen instantaneously. It does not happen, right? And it does not mean that the Bitcoin leaves your computer or goes somewhere. In fact, you never hold the Bitcoin on your machine. What you hold on your machine is the address. Okay. So Bitcoin is a ledger. Okay. Or blockchain is a ledger, continuous ledger. It would say that you hold 100 Bitcoins at say 8 p.m. today. Okay. When you do a transaction of say 10 Bitcoins and you transfer it to say Abhishek, okay, the message is relayed on the network. Miners will take all the uncommitted transactions that have been pushed on the network. They will try to make a block out of it. Okay. After the block is made, they will publish it on the network. There would be other miners who would validate this transaction. Once they have validated that a correct block has been made, it becomes available for all the nodes. Okay, so this process take 10 minutes, and it has been intentionally kept that difficult so that no one is able to double spend. So while the
No, I got
transaction
it.
happens, while the transaction
So
happens in real time,
uh-huh.
you have to wait
So
for
when the
that 10
10
minutes
minutes
for
is
all this.
10 minutes is fine. So
Uh,
I know that within 10 minutes it takes all the time. But why we need to wait for that sixth transaction? You said that we need to wait for six transactions so
right.
that it
So
cannot be reversed.
Agree. So if you see after B1B, there is B2B. Okay.
Mm-hmm.
Now imagine if someone had a lot of processing power. We talked about Sybil attacks yesterday, right? So imagine someone had more than 50% of the processing capacity. Before a real good intentioned miner could be able to do B2, okay, someone with a lot of processing power would go ahead and do B2B. Okay. Then he would
Okay.
again go and create B3B. So similarly, he would have to create up till B6B, okay, so that his transaction, I mean, it is almost impossible to invalidate that transaction. Now, for someone to be able to hold 51% of the internet resources for 1 hour, it is impossible. So you can do some stuff, okay, and get hold of 51 processing power, make one illegitimate block on the blockchain. But while you are doing that, everyone is watching you on the network, right? So they would be able to make out that you are trying to do something which is not legal or it is not the right way, and they would block you out of the blockchain, they would kick you out of the blockchain. So that is why it is said you have to wait at least for 6 blocks to be prepared, so you can say that it has been accepted by everyone on the network.
So this wait time is to validate the transaction, not to reverse it, right?
The transaction can never be reversed, right? But say in this particular case, okay, B1A and B1B were using the same money, right? It was trying to spend the same money. So B1B was the money that was supposed to be received by Bob, correct? But that transaction is rejected. Okay, it is never pushed on the blockchain. We are not reversing it. It is never pushed on the blockchain. It is said that it is an invalid transaction. That is why Bob will never receive that money, because that money was spent with Dave already. So in case, blockchain, you cannot do a swipe card, but if say there was a card based system and Alice was somehow able to swipe it at POS terminals in less than 10 minutes twice, and Alice has got the products, it is a loss for Bob. Okay, because Bob did not wait for 10 minutes before handing over the goods to her.
Hey, Sunil.
Okay.
Sunil.
Yep.
So basically, in other words, what we are saying is, as soon as a wrong transaction is made in the system, then whatever transaction we made after that are going to be automatically invalid.
Correct.
Because the first one itself was not valid. So
Correct. So the entire chain that follows after an invalid block, okay, is rejected. That is why yesterday we read one line on the Bitcoin paper where it said the transaction line with the highest number of confirmations is treated as the ultimate source of truth. Remember that line from the Bitcoin paper?
Yeah.
So that is what we are talking about here. If you see B1 to B6 is the longest chain compared to B1 B2B.
So in your example, I think there should be a cross mark at B1B as well, right?
No, so B1A and B1B can happen at the same time, right?
Oh yeah.
Because right. So at B2B, it would be realized that B1B is the wrong chain, and there has already been a B2. After B1A, there has already been a B2. So the attempt to make B2B is invalid. That is why B1B is invalid. So you trace back to the tree wherein you can find the right transaction, and then you go to the last block. Okay. From B6, if there were other transactions in B2B, okay, someone was trying to make a block out of it. Now they can go to B6, take the hash of B6 and put their transactions in B7. So you have to always follow the longest chain in the block.
Okay.
Still any confusions on this, or it is clear now?
No, I'm good. Thanks.
Okay. Is Sunil having some problem?
Hello.
Yeah, Sunil, I can see you are typing something in the chat.
Okay. No, it's okay. So assuming at first minute, Alice is buying something from seller 1.
Correct.
And second minute she is trying to buy something from seller 2. So that second transaction will be successful at the second minute or not? Or will it wait for the first transaction to be successful?
Correct. So no one is stopping them from, or no one is stopping Alice from doing as many transactions within that 10 minutes as she wants, right?
Okay.
Because for that 10 minutes, she does hold the money. Okay. But after 10 minutes, when the first block is prepared, the first successful transaction that is picked up will go through. Rest of the 9 should be rejected. So as sellers, you should not be shipping the products before you've received the confirmation. If you ship the product without receiving the confirmation, then you have not followed the rules and you'll be making a loss. As simple as that.
Oh, okay, got it.
Okay.
So in that case, okay, I'll ask in future.
No, sure. Go ahead. I mean, let's clear it right now.
so instantly through banks.
Yeah.
We can buy many things. Here I can also buy.
Correct.
So no, leave it. I'll ask in future.
No, it's okay. You can go ahead and ask now.
Yeah, means double spending we can do during this transaction. As you told, Ethereum takes 15 minutes. So for
Ethereum takes 14
15
seconds.
seconds.
Ethereum
14
takes
seconds.
14
Correct.
seconds.
Correct.
Yeah, blockchain takes 10
So
minutes.
within those 14 seconds, I can buy a number of things, but seller has to wait
Seller
for all
won't
the
ship.
confirmation.
Seller won't
Seller
ship.
not.
Seller won't ship.
Okay.
Basically, 13 of your other transactions, I mean, assuming you're doing 1 per second, 13 of your other transactions will get cancelled. You'll not be able to double spend. It is not stopping you from double spending, but it will not let you double spend.
Okay.
Okay.
So
that,
in a
yeah,
traditional banking system, when check used to get bounced, it is something like that, right?
you can say it like that. So in traditional banking also it happens sometimes, okay, where you've got, say, money during the day, okay, it is supposed to get cleared in the night. Say for example, you took a insurance policy, money is to be taken there. In the day they would make a check that you've got the balance, and in the night batch it has to be debited. But before it could be debited, there's an other check outstanding which has come for clearing, and the money gets debited there. So your premium payment for the insurance will get bounced. So it does happen in these things also. Or you've got sufficient money for it, but there are charges to be applied tonight. You've got a monthly billing cycle, so the charges eats up the money, and you don't have sufficient money for paying the insurance.
So in that case, like in this example, is there any penalty or any this thing which is led on Alice for making that transaction
No,
deliberately?
correct. So all Alice is doing is to commit a fraud on the system, right? On permissioned blockchain, that it would not be possible, right? This we are talking about unpermissioned or public blockchain system like Bitcoin, right? Because in Bitcoin you could have users from hundreds of countries, right? And there is no central authority. In a permissioned blockchain, like you have banks in the current system, you would have some designated people who would willingly take the mantle of verifying these transactions. So there obviously would be limited people in the network, and they would be able to verify that Alice is trying to commit a fraud. Based on the mutual decision, they could throw Alice out of the network if she is doing it repeatedly.
Oh, got it.
Okay.
Makes
So
sense.
one of the other major offerings of blockchain is it can create a digital identity for you, okay, and you could be rated based on how you behave on the network. And if you are a person who is doing fraudulent activities, you could be marked, tagged, and removed from the network forever, right? So that is also one of the case for social welfare kind of applications, wherein people who citizens who are good are incentivized for doing good activities, and people who commit frauds or people who commit crimes, they are penalized accordingly. So you could be barred from receiving any social services.
Okay, fine.
Yeah.
So is there any kind of point system? How does it bar how many fraudulent?
Correct. So that is application logic that you have to build, right? That is your specific use case. So you get the platform. What blockchain is basically, it is a database system. It is a distributed database system, right? The application logic that you have to build for your application is to be written on top of it. So you go to the market, you buy Oracle database, right? Oracle database comes with the database operations, but any logic that you have to build on top of it is your application. Same is for blockchain. Okay. So in this particular case, why can the merchant be assured? Because to be able to double spend this money, okay, the sender has to go back and reverse all the transactions in the 6 blocks that have been added after a transaction, which is impossible because they would require control of 51% of the resources for complete 1 hour. Not doable, not viable in this case. Uh, has there been a problem of this sort? So far in 8 years of Bitcoin blockchain, this kind of attack has never been possible. Clear on this? So we'll begin with introduction to blockchain. If anyone has got any questions, you can ask, or I can move on to the next slide.
No, I'm good.
Okay. So if you see the diagram on the right, okay, you've got a block in the middle and you've got chains. This is what blockchain is about. You've got block contain transactions, okay, and it is chained to the next block, okay. So there will be a long list of blocks chained next to each other, okay, and it will always be the case that it is sort of a linked list. So when you have the latest block, okay, you can take the hashes, return it for previous blocks, and you can traverse to the first transaction that ever happened on the blockchain. So if you go to the site Bitcoin Explorer, you search Google for Bitcoin Explorer, you'll be able to see all the transactions that are happening live right now. I will show it in today's session. You can click on it, you can get the previous hash. If you keep doing it, you'll be able to reach the first block that Satoshi created in 2008, right? So that is the beauty of blockchain, that it is automatically audited, right? No one can tamper with the data. Once it is there on the blockchain, once a transaction has been confirmed, it is available forever, correct? So blockchain is a continuously growing list of records called blocks, which are linked and secured using cryptography. Each block typically contains a cryptographic hash of the previous block, a timestamp, and the transaction data. So by design, blockchain is inherently resistant to modification of data. Like I've been saying from yesterday, you cannot edit anything on the blockchain. If you put garbage data, that garbage data is going to remain forever, for you to see your mistake. So blockchain uses a lot of cryptography. As we saw yesterday, it is based on 3 main principles: peer-to-peer, cryptography, and a distributed ledger, right? There's something called as Byzantine generals problem. We're not going to see it today because it does not make that much sense. But if you've got spare reading time, do Google it, okay, and you realize one of the major problems that blockchain solved, okay. Basically, to give you a very short intro of what Byzantine generals is, Byzantine used to be a general who had several platoons which used to help him in a war, but he did not trust these armies to coordinate and attack the enemy, right? And these platoons were located in different parts. So there had to be a messenger which would come from, platoon 1, traverse to his platoon and tell them that we are going to attack the enemy on so and so date, right? Now the other general also doesn't trust this party. So now there has to be a acknowledgement, right? Okay, we've received your message and we are also ready to attack on so and so date. Now that the acknowledgement has been sent, the party sending the acknowledgement needs acknowledgement back saying that I have received your acknowledgement. Okay, same goes. So this goes in a cycle, right? You would never be able to attack the enemy because you don't trust each other. You keep relying on the acknowledgements. So this was a problem that was not solved for a long time, okay, because there was no trust. So either you had to have a middleman to create the trust, okay, or Byzantine's problems would not be solved. So blockchain solves that by placing the trust in the network itself. You broadcast your message, everyone verifies it using some complex processing, and then pushes it on the network. Once it is there on the network, everyone believes that this is the transaction that has taken place. So read about it. It is an interesting read.
So Sunil, you mentioned three things. One is the peer-to-peer. What was the other
Correct.
thing you mentioned?
Cryptography and distributed ledger.
Okay, these are the three types, or what?
Not three types. These are the building blocks.
3 attributes basically.
Yeah.
Okay, for blockchain.
Yeah, for blockchain.
Okay.
Okay, so this is what a typical block looks like. Okay, so say this is snapshot from one of the blockchain implementations, wherein we are looking at block 9, block 10, and block 11. Okay, so if you see the hash in block 9, okay, 00009998 something, right? So in block 10, the previous hash, that is hash of block 9, will always be copied. Okay, similarly in block 11, the hash for block 10 will be copied. So say if you're at block 100 and if you want to trace the lineage, you could always keep checking for the previous hash and you would able to reach the genesis block. The other components are something called as nonce. Bear with me for some time. I will explain what nonce is. Then there's timestamp, the time at which the transaction was committed. And then there are the actual transactions. So actual transactions could be Sridhar, transferred X amount of bitcoins to Sunil. Sunil spent this much bitcoins at a merchant location, and that sort of transactions, right? So group of transactions are put in a block, and rest of the things like hash, nonce, timestamp, etc. is calculated based on a fixed algorithm. We'll see what that algorithm is. So clear with this linked list sort of structure?
Yeah.
Sunil, good point. All the timestamp are same, so this is not an actual message. I've created it just for explanation's sake. So yeah, the timestamps would be different. I just copy pasted the values.
No problem, that happens. So no problem. The diagram makes things really very clear. So one more thing I quickly wanted to verify. So I see all the transactions to be same in these three. I'm assuming like in the second one, in block number 10, there would be transactions which would have happened between block 9 and block 10.
That's correct. That's correct.
Okay.
That's correct.
Okay.
So these are just, transaction number 1 to transaction number 10. There could be, so each block is 60 bytes. Okay. Now, depending upon the data in that transaction, you could be having, say, 100 transactions in one block, or you could have just 3 transactions in one block, right? Because size of the block is limited. So the amount of data that you can put in the block is limited.
Oh, so these are the transactions which happened in that particular block. Oh, got it.
Correct? Okay. So we'll do some, I'll quickly move to the next slides and come back to these. So we'll see what cryptography is. We'll see how blockchain addresses work. We'll see what cryptocurrencies are. We'll see anonymity and digital signatures, hash codes. And on this slide, all of that will add up. So whatever we study between these 4 or 5 slides, all of it will show how a transaction on blockchain works, right? So it might seem like it is, disjoint, or you're getting information which is not adding up. But when we come on that slide, it will all make sense. Okay.
Yeah.
Yeah. So cryptography, all of us know. If you are from the computer science background, I don't need to tell much. Cryptography is basically the science of disguising, or on the other way, revealing information such that only the parties intended to receive that information are able to see it, and only the party which should be able to send is able to create that message, right? So on the right hand side, if you see one of the earliest cryptographic machines, the Enigma machine, it was designed by the German engineer Arthur Scherbas. This was the machine that was used by the German army for passing messages between their various armies that were deployed in various countries. Okay, so Hitler used to give his messages, which used to be encoded using this machine. This machine remained, the cryptography of this machine remained unbreakable for a long time. Okay, there were several attempts. If you remember, maths of engineering, we had Turing machine problems. Okay, so Alan Turing, the guy who proposed those Turing machine problems, was able to break it. Okay, break this cryptography. They were able to break it, but they did not announce that they were able to decrypt the messages. So they were able to decrypt all the messages that Hitler used to send, the position of the army. They would alert their army in turn that, a strike is to be, uh, German army would be striking you at this particular position. By breaking this cryptography, they were able to save a lot of people. And it is said that it is the breaking of this cryptography that led ultimately to for the defeat of Germany. So there's a very nice movie called The Imitation Game, okay, based on the life of Alan Turing, which shows how he was able to crack the enigma. If you have time, you should definitely watch it. Entirely about cryptography and mathematics. So cryptography, like we all know, we also have used it knowingly, unknowingly in our lives. The simplest cryptographic example is Caesar cipher. So Julius Caesar used to use it, wherein if I have to, write a letter and the letters are ABC, me and the other party would decide a cipher, replacement. So for example, I've written example here, 3 is the cipher, right? So instead of writing A, I would skip 3 characters and write the next character. So if the message were ABC, I would instead write DEF. Now the person who does not know the cipher replacement, okay, for him DEF would make no sense, right? That is the easiest and the earliest sort of cryptography that was used. There are a lot other cryptographic algorithms that are used. In blockchain, we use something called as hashing. We'll see what hashing is and the various algorithms for hashing. Engineering days, if you remember, you would have studied RSA, Diffie-Hellman, Euler's algorithm. So these are all algorithms that are used for cryptography. RSA and Diffie-Hellman is used for public key and private key, which is almost used everywhere where we have identity or verification. So in blockchain, cryptography is primarily used for 2 purposes. One is for securing the identity of the sender of transactions, and the other is for ensuring that the past records cannot be tampered with. Okay. So RSA, we all know from college days, it is very complex, virtually unbreakable. The tokens that we get in office for connecting to VPN, okay, those are based on the RSA algorithm. The problem with RSA is, depending on how complex you want to make the system, okay, how unbreakable you want to make it, the key, okay, the private key becomes that large, right? So, for example, if you were to use a 256 byte ECC, okay, with the same level of RSA would have to be 3072 bit key, right, which is very large. But in ECC, which is elliptical curve cryptography, it is just 256 bytes. So blockchain employs ECC, which is elliptical curve cryptography. Similarly, for a 384-bit key in EEC, the RSA would require 7680-bit key, which is virtually impossible to store and remember. So while we want to make the system a lot complex, we also don't want to make it, the cryptography is so complex that users are not able to remember their passwords or not remember their keys. Okay. The other point being, NSA has already declared that a 384-bit key in EEC is strong and secure enough to store the US government's top secret level information, right? Now, I don't think any of us has data that confidential that we even need a 384-bit key, right? To see how these keys work, I will show you a demonstration by showing how these keys are generated. So Bitcoin and Ethereum both use elliptical curve cryptography. When someone sends you money on the blockchain, all they are doing is sending it to your public address that you have shared with them, right? For you to be able to spend that money, you have a corresponding private key pair. So you have a public key, you have a private key. We'll see how both are generated. Okay. So you receive money on your public key. Your public key is visible to anyone. So it is like your email address. You can share your email address with anyone you want. Okay. But for you to be able to read the contents of your email, you need to have a password. So your password is your private key. You should never share your private key with anyone. Public key and private key are both large integer values, and they represent, for brevity's sake, the wallet input format. So there's something called as a WIF. When you create a wallet, your money is basically stored in a wallet, right? In a digital wallet. So you have to create a wallet address where someone is able to send you money, and you are able to keep track of how much money you have in your account. So now let me open the browser and show you how to generate this private key and public key. Just refresh this. You can do it in your free time. So there's a site called walletgenerator.net. You should not be using this site to create an actual private key or public key. Okay, so if you see on the screen, you would, are you able to see my screen?
Yes.
So you would see there are tiny pixels in the background of this entire web page, right?
Yeah.
Those are positions that this website tracks. Now, what if you see it is saying generating new address? Move your mouse around to add extra randomness. Okay, so it has a fixed value, and it wants me to add randomness to it. So when I move my mouse, you would be able to see that as my mouse is moving, certain points are getting created on the web page, right? Green dots are appearing, right? So as I'm moving, also keep track of the text is changing. So the hex values that you are able to see as I'm moving my mouse, those were changing. Based on that, it has created this public address and this private address for me, right? Now I should share, I should store this secretly. The public address I can share with anyone who wants to send bitcoins or any other coins to me. I will have to attach this to one of the wallets. Okay, so I could register a wallet at MetaMask or somewhere. So here, if you see, I have installed MetaMask. Okay, uh, on MetaMask, you could connect to a lot of networks. So the main Ethereum network or a test network, there are several test networks. If you create a local host Ethereum on your machine, you can connect it to local host. Currently, it is connected to my production one. Okay, so you could add your public address here and share it with anyone. When they would send you coins, you would be able to see it in your MetaMask. Okay. You could also create a paper wallet. So based on what was generated, you could just print it and store it for your future reference. Okay. So this is how a private key looks like. Okay. Now, when you share this public key with anyone, okay, they are able to send you money, but they would never know your private address. Okay. Similarly, you would know the public key of everyone who shares it with you, but you cannot know their private key. However, a message that has been encoded using your public key will be decoded only using your private key. So these act in pair. Okay, if no one else will be able to open the message that is intended for you, the message that has been encrypted using your public address can only be decrypted using your private key. So that is the beauty of this, cryptographic algorithms.
So, will my public key be given to all the participants, like when a transaction is happening? So that public key would be will be given to all the participants. And
So
since I am having that
yeah,
key, I mean it's kind of a lock for which only I have the key. No one has that key, so no one would
correct.
be able to open. Okay.
View the contents. Correct.
Okay.
So how it works, right? So for example, Alice wants to send $200 to Bob. Okay, now don't go on the transaction values or the hash values. I've just randomly typed them. Okay,
Okay, no problem.
so yeah, so what she will do is she will initiate a transaction. The transaction is pushed on the block. If you see, the public address of Bob, I've not correctly written it. So this is the public address that is there in the bottom. What will follow in the background is, okay, you need to generate a 256. Alice needs to generate a 256 bit private key, which we just did on the website, right? So that private key she will generate and store it for future reference purposes. Next, the private key needs to be passed through SHA 256 algorithm. So it is one of the cryptographic algorithms available publicly. Okay, you can download the code for it. Okay, you would have the entire process what SHA 256 does. So it is not a secret algorithm. It is available publicly to anyone who wants to view what the algorithm does. When you pass your private key through it, the output will be a hash. So let's call it hash1, right? Now you get hash1, you pass it through another algorithm which is called ripe MD160, right? So the output of that is hash2. Okay. Now what we did, we passed the private key through SHA 256. The output of it was passed again through ripe MD160, and we generated hash2. This hash2 we store, say, in a variable called part A. Okay. Now we will again take the hash2 and we pass it again through SHA 256. Okay, the output is hash3. Hash3 is again hashed through SHA 256 to generate hash4. Okay, the first 7 bits of this hash4, we call it part B, right? Now part A and part V, we add up, and that result is your public address. So that is how your public address is generated. Correct? You know the algorithm, you know the process. Would you be able to guess someone's private key? The entire algorithm is available to you, right? You could just backtrack it and you can generate the 256-bit key that we provided in step 1. Should be possible, right? Because you know the algorithm and you know all the steps that have happened.
Right, backtrack and probably yes.
Yeah. So read the answer there. You could do it. It would only take you 4 followed by I don't know how many 0 years to complete this calculation backwards. And we're not talking about normal computers, we are talking about supercomputers trying to break this stuff. So that builds your confidence in blockchain, in the cryptography of blockchain, how secure the system is. Yesterday we had some questions around, how secure it is. So it is this secure. Unless due to a human error, okay, or human stupidity, you unintentionally share your private key with someone or lose it. You've written it on a piece of paper and lose it, in which case no algorithm, no computer, no security can save you. Right? So it is unhackable in terms of the security is providing, but it does not account for human errors.
So one more question. This public key and private key need to be generated only once, right? It doesn't need to be generated for each transaction, right?
Yes, correct. But there's another angle to it. Okay. Say you generated one private key and one public key. Okay, and this is very hypothetical example. You want to remain anonymous on the blockchain. You never want to be traced, right? But if you're using the same public key, okay, and tomorrow you do a transaction at a merchant, okay, so the merchant will have your public key. Now, obviously, to ship the products, you will give your actual name, your actual address. That also goes on the blockchain. So you are ultimately exposing yourself on the blockchain. So if you are dealing in kind of applications where you want to remain a ghost on the network, it is advised that you generate a new pair of private key and public key each time you do a transaction. Not needed in real life, but just a precaution. If you really want to remain anonymous, you should try to create a new public key, private key pair each time you want to do a transaction.
So Sunil, I have one quick confusion here. So basically, if you look at your first step, it is like generating a 256 private key, and correct. From that private key, my public key is derived.
That's correct. So when I moved my mouse randomly over the screen, okay, I was generating my 256-bit private key.
Okay.
Now, for someone to be able to have the same private key as me, he would have to, I mean, using this tool, right? There are other tools also to generate. So you could generate is using passphrases. So most common way is if you register on one of these websites, they will ask you to type 12 random words. Okay. They will pass those 12 random words through an algorithm to generate your private key. Now, what are the chances of someone moving the mouse on the screen exactly the same way for generating those many dots and be able to match the same pattern that I did? Very less. Even if I want to do it myself, I won't be able to do it unless, you know, I really spend years trying to master the movements, right? For someone to be able to come up with 12 exact words or phrases as me, again, it has to be a very, very big coincidence that, you know, all the 12 words match in the same order that I have spelled. So they make it very difficult for someone to guess your private key, right? How your private key was generated. That is why one of the biggest disadvantages of this much security is, consider the current scenario. Okay, you have got say $100,000 in your account. Okay, online banking. Say the bank doesn't support branches, doesn't support ATM, so there is no other way you can get the money out. You forget your password. You would be worried, but you would not be worried that much, right? Because you can always reset the password. You can go to the bank, tell them I forgot my password, please verify me and let me generate a new password. On blockchain, if you've forgotten your private key, okay, if you've lost your private key, that money is gone forever. There is no way it can be recovered.
I see.
And this has happened with people, right? So people in the initial days when Bitcoin did not matter much, okay, it was $3 or $4, people bought it say for $200, $500, and they forgot it. Okay, when they realized now it is $7,000 or $10,000, they wanted to retrieve that money, but there was no way they could retrieve it because they'd forgotten the passphrases that they had used.
So in banks we call this something called as NPA, non-performing assets. So these are non-performing assets in the blockchain. Whoever forgets the private key.
Yes. These are lost assets. No one can claim them.
So, Sunil, it's a little bit confusing for me. Okay.
Yeah.
So suppose you are sending money to me,
correct,
or I have sent money to you. So what
correct,
will you do? You will give some passphrase. Based on that passphrase, a private key and public key will be created for you. That public key you will send me. Okay, send money on this public key.
Correct.
And for me also, I will.
So you will also have a you will also have a
key for me.
Exactly. So for anyone to be able to participate on the blockchain network, they will have to have these two addresses. Okay, public address is for the external world. Okay, so that they can send you money or they can verify it as you. The private key is for your own use.
Okay. So for me, because I have to send money to you, I will generate also my public and private key.
That's correct.
And then only I can send money to you.
Exactly.
Yes. So why this public and private key do I need? If I have to send money on your public key only.
But how do I verify the money is coming from you?
Okay. So it means with that transaction, my public key will be attached.
Correct. So not your public key will be attached. You will encrypt the message using your private key. Okay. And I will decrypt it using your public key.
Okay.
So that will let me know that it is indeed you. So there are two parts to it, right? First is verification. So for me to be able to verify that the message indeed came from you, okay, there will be part of the message that will be encrypted using your private key. Okay. Now anyone on the network who has your public key would be able to decrypt it that the message came from you. Okay. But the actual content of the message, no, we are talking about identity here, right? So me and everyone on the network is able to verify that the message indeed originated from you, right? But the actual content of the message would be encrypted using my public key. Okay, so others on the
Okay.
network would not be able to decrypt that information. That information only me can decrypt using my private key. So it serves for both the purposes. I've been able to identify the I've been able to verify the identity of the person who initiated the transaction, and the actual message
Okay.
was encoded in such a way that only me, who is the intended recipient, is able to verify or read the message.
But one more thing.
Yeah.
Whatever public key I have shared,
Hmm.
how someone can know that it's me? I have not given any information over that.
So I don't need to know whether it is, whether it is Pankaj or whether it is Sunil or whether it is Abhishek or whether it is Ashok. For me, you are just an address,
Okay.
right? So you share your address with me. We do transactions on that address. You could be having 100 addresses. I don't care. As long as
Okay.
we two use addresses to interact with each other, okay, and you agree that you would receive, you would sell me goods if I send money on this address, I would trust that.
Okay. It means simply keeping it simple. Whatever address I am sending you, whatever message I am sending you, all will be encrypted using your public key, and using your private key you can see that, but
Correct.
none of means others can't see other
No
than
one else on
you.
the network. Exactly. No one else on the network should be able to see, and no one will be able to see.
Okay, that's great.
Okay. Should I move
Yeah,
ahead?
yeah, please.
Okay. So next is an introduction to cryptocurrency. Cryptocurrency is basically digital assets, okay, or digital form of money. They are built on the blockchain technology, and they exist only online. You cannot have a physical digital currency, okay. And all of them use cryptography to verify and secure transactions, hence their name crypto. And there are currently, maybe this figure has again increased, there would be like 2000 different cryptocurrencies available in the world. A lot of them are dead, okay, someone created them, it is no longer used, or it never picked up, it got created and there was never a single transaction that happened on those cryptocurrencies. The most famous one is Bitcoin, okay, which was the first cryptocurrency that came in back in 2008 2009. That is considered the gold standard in crypto space. Like you have, like in terms of normal currencies, you have USD, at which all the other currencies are pegged, okay. So when you are doing a trade for currency, it is always valued in terms of dollars, right? So if you want to do trade in Indian rupees, you convert it to equivalent USD, and both the parties are talking in terms of USD, right? So similarly for cryptocurrencies, Bitcoin serves that purpose. So if you want to buy, say, Ethereum, you cannot, you can now, but not for all coins, right? So for example, if you have to buy Ripple, you go and buy Bitcoin first, okay, and then send that much, whatever amount of Ripple you want to buy, you send that Bitcoin to the Ripple company, and Ripple will give you that amount of Ripple currency equivalent to the Bitcoin that you send them. So in that way, Bitcoin is a gold standard for all other currencies. All other currencies at the trading desk are pegged at their equivalent Bitcoins. Ethereum is the second most popular crypto coin, founded by Vitalik Buterin, uh, a very young guy and very respected in the crypto space. And if you are interested in trading cryptocurrencies going forward, which I really don't do and I don't recommend to a lot of people, to me it is gambling, okay. So if you are willing to take that kind of risk, obviously the gains are way higher, okay. If you're willing to take that risk, go ahead. You should follow Vitalik Buterin, his advices on Twitter or in his uh, blogs are exceptionally good. So there are certain people that you should be following if you want to know the latest happenings on the blockchain space. Vitalik is one of them. Then you have Don Tapscott. Uh, he is very well researched. Don and Alan Tapscott, they are fathers and duo who have done a lot of work in the blockchain space. Uh, Probably on email, I'll share a couple of more contacts so you can follow these guys if you're on Twitter, LinkedIn, Facebook, etc. They keep sharing a lot of interesting stuff. Ripple, uh, Ripple is a strange coin. Okay, anyone who is there on the blockchain network and respected a bit will say Ripple is a bad coin. Ripple, some people have termed it cripple, right? But Ripple is the only coin that is been adopted by banks, that has been taken by banks in taking their blockchain agenda forward. Ripple is also mainly trying to do away with international transfers. A lot of banks are currently using it. So instead of going via Swift, which is a conventional network for uh, monetary transactions, they are using Ripple for doing it, right? But the blockchain space or the blockchain ecosystem doesn't respect Ripple because they think so the ultimate reason why these guys came up with an alternate or parallel economy was they thought banks are evil, right? They wanted to get away from banks, and they think with Ripple banks are making a backdoor entry in the blockchain ecosystem again, so they are not very supportive of Ripple. Litecoin is now, it has picked up really great. I would peg it right after Ethereum. So it is much faster than Bitcoin, and it has got large amount of tokens and better mining platform than Bitcoin. Monero is again another very popular coin, and it has more privacy features than Bitcoin. If you use Bitcoin, every transaction is documented in the blockchain, and the trail of transactions can be followed. Monero keeps it a little fuzzy. It is not that easy to identify which transaction was initiated from where. So these are the top 5 coins that are traded actively, that are researched actively and used for blockchain implementations. There are a lot of other coins. If you are not knowledgeable about them, my personal recommendation is don't fall for short-term gains and invest into it. It is a very risky proposition. If you love your money, stay away from these unless you understand it or you are willing to risk that money and you are okay to lose that money in case the markets crash. Because these cryptocurrencies, it is very normal for them to see upward swings of up to 50 to 100% in a day. Similarly for downward trends. So the currency could be trading at $5,000 in the day. You take a 2-hour nap, you wake up and see now it is trading at 2,500, 2,800. So unless you are willing to take that kind of risks, stay away from them.
Hey Sunil, I have one question. It's not very clear to cryptocurrency. So I understand $100. What does this mean? I can buy 20 gallon of milk or this amount of some goods.
Good question, and I get where you're getting, right? And there is no inherent value that cryptocurrencies offer. Okay, it is only hype. It is only hype that is driving these prices, right? So Bitcoin, it is said, it is by design there cannot be more than 21 million Bitcoins. Okay, now it has become a scarce resource. Everyone knows that there can never be more than 21 million Bitcoins. So whenever that is exhausted, I will not be able to buy any more Bitcoins. So I should amass as many Bitcoins as I can now. Okay. So they will pay more price for it. Okay. That is how Bitcoin went to 17,000, 18,000 levels, right? But there is no inherent value. Tomorrow the government can come forward and say Bitcoin is banned in the US, in the China, in Korea. These are 3-4 major markets where it is heavily traded, and you could see Bitcoin trading at zero because there is no inherent value. So the only way they are having value is because people are willing to pay more for it. They see value going forward, and that is why they are ready to pay that kind of money. But like fiat currency, like it has the backing of gold or the backing of respective countries' governments, Bitcoin or for that matter any other coin does not enjoy that backing from the government. That is why I repeatedly keep saying it is a very risky proposition. Venture into it only if you are ready to lose the money. There are crazy gains, but then you could lose everything overnight.
Okay, so I have one question basically. So as I know, India can print only this much amount of rupees because it has put so much amount of gold in the World Bank somewhere.
Correct.
So that World Bank is controlling how India can print notes. What
In fact,
about
it
this
is not. It
cryptocurrency?
is
Who is
not.
printing?
It is not okay. So both points. It is not World Bank that decides. In fact, US does not deposit any gold. US keeps printing dollars when they want. There is no actual backing. Cryptocurrency, on the other hand, when a block is placed on the network, okay, each time a new block is created, new bitcoins are created by the platform. So whenever a miner solves a block, 12.5 bitcoins are released and given to the miner for the effort that he has spent in mining, right? Earlier it used to be 25 coins. Before that it used to be 50 coins. So every 4 year this amount gets halved. Okay. So for example, today a miner is getting 12.5 coins. Probably the next review is up in 2 years. After 2 years, once the review is done, from that day, a miner would get only 6.25 coins for solving a problem. Next year it would be half of that. Next year it would be half of that. So by 2040, there would be no more coins to mine. Okay, all the coins, I mean the 21 million coins that the Bitcoin system is designed to have would be mined by 2040 if Bitcoin blockchain remains live till 2040, right? Post 2040, the amount of Bitcoin is finite. It is just 21 million, right? So if someone wants to do a transaction, he needs bitcoins to pay, right? Now, if I'm holding 100 bitcoins, okay, and he's got $100,000 to transfer from country A to country B, I could tell him that I will be selling you bitcoins at the rate of say $50,000 per bitcoin. If you want to buy it, pay me that kind of money. So that is the only reason people are trying to stash bitcoins for now.
So exactly this I want to understand a starting base case from where this is the X amount of Bitcoin from where now we are starting. People can buy our coin. Could we have some diagram where we can see in the next session or any time? What was the initial stage?
So at initial stage, there was a time when someone traded 10,000 bitcoins for a pizza.
Okay.
So what does a pizza cost in US?
$20.
It's around.
Yeah. So at some point of time, $20 or $30, whatever was the worth of pizza, was traded for 10,000 bitcoins. So whoever made that trade, and if he kept those bitcoins, he would have made probably
Sorry
billions.
for asking, Sunil. Sorry for asking so many questions.
Yeah.
But from where he got those 20,000 points, and from where he got those points?
Correct. So initially, when Bitcoin started, right, like I said, when you solve a mining problem today,
Fine.
when you mine today, you get 12.5 coins. When it started, it would have been probably few hundred coins whenever you solve a problem. Okay, and
Okay.
the problem. So whenever this review happens, right, 4-year review, at the same time they also increase the difficulty of the problem. So
Who
when
increased?
it is a block Bitcoin group, right? So
Okay, there is some
people
group.
were,
Okay.
like for Ethereum, you have Vitalik and his team. For blockchain, also there are certain people who decide that it is time to increase the difficulty for miners. Okay, so at the initial stages, the difficulty was not there. You could mine it using your personal computer, right? So people mined, people bought. There was a time when it traded for a few cents. Okay, when it first hit that one Bitcoin equals to $1, it was big news. And
Yeah.
then Bitcoin rose from 2,500 last year to 17,000, 18,000 levels.
Okay, and now today, suppose I want to buy some bitcoins using dollar, I can buy that. But
Yes.
after getting those points, again, I want my dollar back. Can I get that?
Yes. Yes. So,
Okay,
yes, what you can do as a week exercise is create an account on Binance or one of. I mean, Binance is very famous in US, but there are other exchanges
Coinbase.
also. Yeah,
right.
Coinbase. You could create
So
it
Sunil,
there.
I can show you. So probably we can
No,
meet
that
afternoon. I can show you. It's a,
oh, that will be great, sir. Thank you. I'll catch you.
Yeah, so you guys can show it to each other. And I mean, just to get a feel of it, I would still say, go ahead and create an account. Don't invest any money unless you really understand it. Okay. Or, invest very small amount that you're ready to lose if you do certain trades. But get a hang of it, how it works, and you will be able to connect what we are speaking here on the actual blockchain.
Sunil, this is Vinay. I have just one basic question.
Yes, Vinay.
So you were saying that there is a group which is controlling and which is increasing the complexity of algorithms every 4 years.
Yes.
So this is again going back to the banking where
No,
there is a
no,
central
no, no,
system which.
no. So it is not. It is not that they are owners of the blockchain system, right? These are people who are contributing from the community. It is not that they have certain stake or what they say is finalized.
Okay.
Okay, and it is by design in the platform itself. It is not that they can say instead of halving it, instead of making it 6.25, make it 1500 so that I can mine and I can make profit out of it. It is the way Satoshi designed the blockchain system that it will automatically reduce it to half.
Okay.
Okay. So next, these are the various attributes of a cryptocurrency coin. I've taken it from Blog Geeks. It is a very good site that you should be referring to keep yourself abreast with new information that is coming in the crypto space. Any cryptocurrency transaction is irreversible. So basically, after a confirmation of a transaction, it cannot be reversed. We've seen that. Nobody can reverse it, and by nobody, it means nobody. Not you, not your bank, not the president of US, not Satoshi, not your miner. No one can do it. If the transaction is done, it is done. That is one of it is offerings that we are seeing as advantages. Say today you are doing a transaction, you by mistake send the money to a wrong Sunil Pandey instead of me. You could immediately contact your bank. You can tell them that you've done a wrong transaction. The bank would be helpful and they would help you recover your money. But if you do it on the blockchain, it is gone forever. Whoever received it is free to keep it. They are not obligated to return it to you. You send it, the transaction is confirmed, the money is gone. In terms of bank, if the bank gets hacked, they would obviously go ahead and pay you, right? Unless the entire bank got hacked, okay, and they go bankrupt, nothing can be done. Still, the government would pitch in, government would pay on behalf of the bank. We all know the Nirav Modi case, right? It is not that the depositors are told that Nirav Modi fled with this amount of money, so what we are doing is we are debiting your account by 10,000 to make up for the loss of the bank. Cannot happen. But in crypto space, the exchange gets hacked, coins are lost, it is lost forever. So there's an exchange called Mount GX in US, which was hacked, and I think 500 million worth of bitcoins and other coins were hacked, and ultimately they had to shut trading. The company went bankrupt. So whoever had their coins placed there, no one is going to refund it to them. So that is one aspect, that it is very secure, but in the same way, it is so secure that if a transaction has happened, it has happened. Nothing can be done to reverse it. The next is pseudo-anonymous. So we saw that your identities are never revealed on the system. It is always addresses that we are talking about. Uh, Anyone who is doing transaction with you doesn't need to know who you are, where you belong, where do you stay, what do you do. All they require is your address. They will send the coins there, and it is done. Fast and global, unlike fiat money, where you require a lot of middlemen to carry the money and do the transaction entries in their ledgers, pass it to the next person in the chain. It is instant, it is fast, it is global. It doesn't matter if I send Bitcoin to my neighbor or to someone in the other part of the world, it will take the same time. If it is 10 minutes for confirmation, it doesn't matter whether I'm sending money from India to US or whether I'm sending money from my account to my wife's account. It will take the same time. Secure cryptocurrency funds are locked in public key cryptography. So we saw how public key cryptography and private key cryptography ensures identity validation and make sure that no one else is able to read the messages. So same concept applies to cryptocurrency. No one else is able to read messages intended for you, and you are always able to verify where the message originated from. Public blockchains are permissionless, so you don't need to ask anyone. You don't need to get someone's permission before joining the blockchain. Just generate a private key, public key, and you are up on the network. You can do all sort of transactions that are available for everyone. So there is no privileged user. There is no entitlements, no block, transaction blocks, etc. Whatever is available to the CEO of one company is also available to anyone like us. So there is no differentiation in terms of service offerings. Whatever is available to one person is available to everyone on the network. Clear on this?
Yes, sir.
Okay. Okay, so how it works, right? Someone requests a transaction. Okay, you see from the top left, someone requests a transaction. The requested transaction is broadcasted to the peer-to-peer network consisting of computers and nodes. Okay, it does not go to a single server. It does not go to a bank server or any such place like that. It is automatically sent on the entire network. Anyone who is connected on the network willing to listen to the message will receive the message. Okay. Validation. So the network nodes validate the transaction and the user status using known algorithms. How can you verify the user's status? They would have signed the message using their private key. You have their public key. You would be able to decrypt it. So when you are able to decrypt it using their public key, it means the message definitely originated from them, right? So you are able to verify that the person who sent the message, who claimed that he sent the message, is indeed the person who sent the message, right? Then when the transaction is validated, it is put on the network. Verified transaction, it could involve cryptocurrency contract or records or any other information. So not necessarily all this has to be done only for cryptocurrency transactions. Suppose it is a distributed database where we are adding a record of a new person. It is a KYC application, right? As soon as the details are pushed on the network, someone runs the algorithms, verifies, the block is created and block is placed on the network. So it is the same thing in case of cryptocurrency or any other use case of blockchain. Okay. Once verified, the transaction is combined with other transactions to create a new block. So it is not that one transaction will create one block. There will be a group of transactions that have happened during that duration, which fit the maximum block size. Okay. If there are transactions more than the worth of maximum block size, then those transactions will have to wait. Okay, so new block is created and the block is then added to the existing blockchain. So you take the hash of the last available block, keep it as the previous hash, you generate your new hash, which becomes the next hash available for the next block that is being created. So this is the entire cycle for the transaction to be completed. Now cryptocurrencies, it is medium of exchange created and stored electronically on the blockchain. And Bitcoin is the best known example of cryptocurrency. We've obviously seen the other coins. Like I said some time ago, cryptocurrencies have no intrinsic value, right? So you cannot redeem it for any other commodity. It is only the perceived value. Okay, so if a person has got gold and he values Bitcoin, you could tell him that, if you give me 10 grams of gold, I would give you, say, half a Bitcoin or 2 Bitcoins, depending upon whatever the value is currently. I think it is $7,500 currently. So the person agrees, he views value in that transaction, you can do it. Otherwise, there's no intrinsic value. Warren Buffett once quote, I like that explanation for him. So he says, would you be paying $10,000 for a check which says, $500? If the check is created in, say, a very good paper, if the check is signed by someone who is a very renowned personality, would you trade for it? No, because no matter what differentiate the check, who signs the checks, or which bank is going to give you the money, the amount that is entered on the check is the ultimate intrinsic value of that check. If it is $500, it is $500, no matter who goes to encash it. But Bitcoin does not have any intrinsic value. And what purpose does Bitcoin serve? Transaction of money, sending money from point one to point two, sending money from account A to account B. That is what Bitcoin is doing. So there is no other intrinsic value. If you're not willing to pay any extra amount for a check or a demand draft, why are you paying it for blockchain, for Bitcoin? And I agree with it. The other point is it has no physical form, exists only in the network. Supply is not determined by a central bank. So, like some time ago, I think it was Vinay who said the central banks of the country decide how much currency could be printed and how much currency could be in circulation. There is no central bank in or any central authority in case of Bitcoin or any other blockchain. Bitcoin, though it has limited, limited coins like 21 million. In case of Ripple is different from other coins in the sense that Ripple has pre-mined coins, right? So they, like in case of Bitcoin, you solve blocks and new mines are unearthed or come into existence. In case of Ripple, the coins are already there. So a majority stake of the Ripple coins, which is XRP, is held by Ripple Labs, which is the parent company of Ripple. And that is why, like I said, people in the crypto space or people in the blockchain space are not happy with Ripple because they are ultimately doing what banks have been doing for centuries. So they are almost acting like a bank, and that is why banks are promoting Ripple. Anonymity and pseudo-anonymity, we've seen that it is ultimately only the address that gets sent on the network. No one knows who is behind that address. If you want to remain anonymous forever, you could be creating X number of addresses every day, and you could encash your dollars or whatever money from these addresses. No one would know who is really behind that obscure address on the internet. If you see at the bottom, I've pasted transaction view of one of the transactions. So that is the address on which the money has come. If you see, it is 0.199 BTC, the balances. Post that, there have been 16 confirmations. We saw about confirmations some time ago. So this information is available publicly. I will go to the Blockchain Explorer website and show you. Okay. But I cannot make out from this information who is the person who did this transaction. I can see that 0.199 bitcoins were transferred from this address to the other address. I can see the timestamp at which it happened. I can see the previous block. I can see the next hash available, but I can never make out which person did this transaction, or even if it was a person or it was a machine who did a transaction. So that can never be found out. So if you read this particular part, I'll just if you read this part where it says in the original Satoshi white paper, it was recommended that Bitcoin users use a new address for each transaction to avoid the transaction being linked to a common owner. This would be equivalent of writing many books under different pseudonyms. So authors write book under pseudonyms so that no one knows who actually wrote them. So Satoshi recommend that for each transaction that you do, you create a new address pair so that it is never that one is able to find out who made these transactions. Very cumbersome, not required at our level unless you are working for the raw or MI6. But if you want to have full anonymity, this is a way to do it. And by the way, though we say it is completely anonymous, it is completely this and that. Like I said, FBI last year said that they've been able to track Satoshi. So, tracking us is no big deal for them.
So yesterday your voice was not clear. So they were able to track it, Satoshi?
Sorry?
I was not able to follow yesterday. So they were able to track Satoshi?
Okay. I thought you were asking me, they were able to track me. So there was a report published by FBI where they said they've been able to find out who Satoshi is based on his writing style. So the original paper that was published by Satoshi, okay, they ran some text matching algorithms on that, okay, and they ran the same. They tried to find the same results on other papers that were published by that were freely available on the internet. So the other papers, they say Satoshi is writing style and they believe it is the same person. They did not reveal the name of the person, but they said that they've been able to trace who Satoshi is.
Oh my. Okay.
Okay, next is digital signatures. So digital signature is nothing. Basically, we all do signatures, right? Now all of us sign differently. That is why it is being accepted by banks as a mean of verification. They are able to verify that it is indeed you. So digital signatures are just the digital counterpart of them. A digital code, okay, generated and authenticated by public key encryption, is attached electronically to the documents to verify its contents and sender's identity. So sometimes when you receive a PDF, okay, which is normally from the government agencies, etc., when you open it, it will say, fail to verify signatures. Click on this particular button to verify whether the transaction was actually, whether the PDF was really created by that person. So that is digital signature. Adobe PDF offers that feature. It is the same mechanism that is written here. So you've got an electronic file. You run it through an hash algorithm. The hash algorithm will generate a hash value. Okay. And then you sign it using your private key. Okay. So the encrypted hash is then added to the file and the file is transmitted. Now, when the file is received at the other person's terminal, okay, they will use your public key to decrypt it. So if they are able to decrypt it, it actually means that you are the person who signed it. Correct? So they're able to verify your identity. That is what banks also do. When you sign a check, you put your sign on it. They already have your signature in their signature verification system. They will open it and try to match your signature on the check with the signature that you are given during the time of account opening. So this is how digital signatures eliminate that process. You don't need a manual verification for signatures. So how it works, when you click sign, a unique digital fingerprint called hash of the document is created using a mathematical algorithm. We'll see how hashes are created. The hash is specific to this particular document, right? So now if I tamper the document even a little bit, if I change the comma to a full stop, the hash value will change drastically. Okay. So with the message, I also send you the hash. Okay. At your end, you will use the same steps to create the hash. When you see that the hash values are different, you will realize that the document has been tampered with during the transmission. So you will not accept it. Now, if you download stuff from the internet, sometimes you will be able to see below the file MD5 hash and then some hex values follow, right? So that is hash of the file that is being computed by the author of that file. So if you don't trust it, and if you feel that someone would have edited the value on the servers, you run the same MD5 algorithm, hash algorithm on the file. If the same hash is generated, that means the file has not been tampered with. If even there has been a slight change, uh, automatically the hash value will differ a lot, and you would be able to make out that someone tampered with the file. Okay, the point 2, the hash is encrypted using the signer's private key. The encrypted hash and signer's public key are combined into a digital signature, which is appended to the document. So document, this is how you digitally sign the document, and the document is now ready for distribution. Now this is the signing process. There has to be a verification process also. So for verification, the other party has a digitally signed file, and they have the file data. So they will run the hash algorithm on the file data, and they will get the hash value. And for your encrypted signature, okay, they will use your public key and generate the hash value. And these hash values are combined to see if they are equal. If the hashes are equal, that means the signature is valid. So that is how verification takes place. So when you open the document in a digital signature capable program, example Adobe Reader or Microsoft program, it will automatically detect that there is a signer's public key, okay, and it will try to decrypt the document hash. And the program calculates the new hash for the document. If the new hash matches the decrypted hash from step 1, program knows that the document has not been altered and displays a message saying that the document has not been modified since the signature was applied. And that also validates the public key used in the signature belongs to the signer and displays the signer's name. So this is the same concept that is used for transaction signing and identity verification in blockchain. Now we've been talking a lot about hash codes. This is how hash code works, right? So SHA-256 is one of the hashing algorithms that is used. We saw when we were creating the public key address, right? SHA-256 is used in 3 or 4 steps there. So if you pass the letter A, okay, or the entire book of Romeo and Juliet as an input to the SHA-256 algorithm, it will generate a fixed length output. This is very important. See, if you are passing just one character or an entire book, the entire book may have, maybe 10,000 or more than that characters, correct? It will generate a fixed length output. Okay, so hash function is any function that can be used to map digital data of arbitrary size to digital data of fixed size. So input can be any size, output will always be fixed size, and slight differences in input will produce very big differences in the output data. Okay, so these are the other algorithms: MD5, SHA1, SHA256. Now I have run this MD5 algorithm on small case ABC and small case AB capital letter C. Okay, if you see the hash values, see the difference. So I've just changed the case from small letter C to capital letter C and see the difference in uh, the hash values that are generated. Okay, and I've run the below phrase: the quick brown fox jumped over the lazy dog, through the same algorithm, and this is the output that was generated. Right, so no matter what is the length of the input, the length of output always remains same. Slight change in the input will cause a drastic difference in the output data. So that is how hashing works, and that is why it is such an important and heavily relied algorithm in the blockchain space.
So one question, are you going to
Yes.
cover how these algorithms are run, this MD5 hashing algorithm?
No, I'm not going to cover that, not part of blockchain, and you're not really required to know how it works. The algorithms are freely available on the internet in almost all programming languages that you want, right from COBOL to all modern languages. You just pick up the libraries, integrate it, most modern languages automatically have it as packages. So Python, Java, etc. would already have it available as a package. You download the appropriate package, just give a call to this function, and you are ready to go. You don't have to write this algorithm ever. Okay. Um,
So, Sunil, so if you look at your ABC code, so if I suppose know that hash code, then from that I can decipher that it was ABC, right? That code would be always same for the ABC.
for ABC, yes, it would always be same. So for ABC, you can remember this, get it. There is no real life use case of hashing ABC. If I were hashing Romeo and Juliet, uh, you could probably remember that. Okay, but it will only tell you what is being hashed. You would never be able to get the. So like we saw, it took you 4 into I don't know how many 0 years to decrypt it. You would know the hash value, but you would never be able to backtrack it and guess what the input was. In case of ABC, it is easy to remember. Would you be able to remember the entire Romeo and Juliet? I doubt. Same for any other stuff. So the beauty of any of the cryptographic algorithms is it is very easy to compute it in the forward direction. It is almost near impossible to derive the input from the output. That is why these algorithms are freely available. You can inspect the code, you can run whatever test you want on it. They are so complex in terms of mathematical probability that you'll never be able to backtrack it. There's a common saying in security world that you should spend only so much amount on securing information that the cost of breaking it, okay, the cost of breaking the security should be more than the value of that information. So if you are to spend say $10,000 on finding out my email password, the contents in my email box should not be worth more than 10,000. Something of that sort.
That makes sense.
Right?
Makes sense.
Okay, so whatever we studied till now, we studied a lot of different things, disjoint things. This slide will tie them all together, right? So if you see on the left side, there is a pool of uncommitted transactions. So all of the transactions that have happened in the last 15-20 minutes or whatever time duration, okay, they are in this pool of uncommitted transactions. Now say our guy Dave, he is a seller, he is also a Bitcoin miner. So he's on the network, he sees there's a list of uncommitted transactions, he's got spare processing power, he could create a new block, and if he is able to solve the problem, he would be able to get 12.5 Bitcoins, which is huge money, right? So he takes then some transactions from the available pool so that they are within the block size. Okay. Now to create a block, what does he need? He needs header of the most recent block, which because he requires the hash from the last block, right? So from the last block he will get the hash. Now he has to generate hash of the new block, which will become hash for the next block that is getting generated, right? So he needs to generate that. To generate that, he needs something called as nonce. Nonce is basically number for one's occasion. We'll see what that means, right? Now let's focus on the diagram in the center itself. So he has proposed new block of transactions. He has header of the hash of the last block. He needs to create hash of the new block. The hash of the new block should be such that it is less than the target value, which is specified by the blockchain implementation. Okay. So if he is able to generate a new hash, which is less than the target value, he has been able to solve the proof of work. Proof of work is a solution, right? We'll get to what proof of work is, but for now think that it is a puzzle. Okay. And he's been able to solve the puzzle. If he's been able to solve the puzzle, he should have generated a hash which becomes hash of the new block. Okay. Now how that happens? So one of the tests is called as 5 leading zeros test. Okay. and don't go by the values that are written here. These are just example values, but the algorithm works exactly like I would be explaining. Okay, so say header of the previous block was DFGD3434. Okay, what follows? In the proposed block, the transaction read this is a test message. Okay, so what will he need? He will need the previous block. He will need the current hash of the message, and he needs to find something called as nonce. So he guesses a random number, say 115465. Okay, and he runs through them through the hashing algorithm, and the hashing algorithm generates this particular value. Okay, it the value is 001200124. Now, does it have 5 leading zeros? It does not, right? Which means the hash number is not less than the target value. See this? It has to be less than the target value. So 6 zeros would have been fine, but at least 5 zeros we need. Okay. So what he will do is he will increment this number. He will try 115466, or he may be good at guessing and he would directly try 786594. Okay, whatever way he wants to do it. Okay. So he keeps trying this until he comes across 987159, which generates the output 5 zeros 4FFQH, right? So does this match what we need? Yes, right? It passes the test. So this number 987159 becomes the nonce, okay, number for one's occasion. So that was the missing piece in this particular loop. We are to calculate the nonce. Now, do you realize how difficult it would be guess this number? Right? That is why you need
Sunil, but in this case, 5 leading zeros, just what does this mean?
So you have to generate an output using the algorithm. So there is one algorithm, okay, which takes as input header of the last block, which takes as input the data for the new block, hash of the new block, and it needs a random number, okay, a seed number. When all these three are passed through the algorithm, it needs to generate a hash. It is an hashing algorithm. It needs to generate a hash which will have 5 leading zeros. Okay, so it should be 000.
No. That is only my question basically. Why 5 leading zeros? Why not any other number basically?
Correct. So when the Bitcoin, I got it. So when the Bitcoin started, it would have been 2 leading zeros or 1 leading zeros, right? It is very easy to generate 2 leading zeros. Okay. When I raise it to 3, the difficulty is raised exponentially. When I increase it to 5, you realize how difficult it becomes, because you have to guess a lot of numbers to be able to generate 5 leading zeros. Correct? So when I spoke that every few years these guys meet and increase the difficulty, this is what they do. So probably next time they meet, they would say that the difficulty needs to be increased. We need a 7 leading zeros test, right? So the difficulty is increased exponentially. You would have to run a lot many combinations to arrive at the nonce, which will give you 7 leading zeros. Right? This is one of the algorithms. There are different tests that they will have in that particular blockchain implementation. So this is one of the tests. To get the concept remains same. Okay, you will have to calculate something which suffices the algorithm when you have solved that. Okay, and why this is necessary. What is this algorithm called? Proof of work, right? What you are doing trying to guess this value, you are doing some work. You are spending electricity, you are spending computing power, you are spending bandwidth, etc. So you are doing some work. That is the proof of work that you have been able to calculate this nonce. As soon as Dave is able to get the right nonce, he will create the next block. Okay, and that basically this thing you have solved the proof of work. He will push the block on the network. Okay, with the nonce value. So he will say, I have prepared this block. The nonce is this. For example, 987159. Now the other miners on the block, okay, they once they know the value 987159, they are it is very easy for them to validate. They will run the same algorithm using the same nonce, and they'll be able to verify, yes, he's able to pass the leading 5 zeros test. So a proof of work is a publicly auditable cost function that can be efficiently verified by any third party without access to any trapdoor or secret information. But it should be equally difficult for the person who's creating it. So verification should be very easy. Okay, but generating it the first time, finding the solution should be very difficult. This is what all the blockchain implementations target. Okay, so you have to keep it very simple for the person who's trying to verify it, but it has to be very difficult for the person who's trying to do the mining or who's trying to place the message or place the block on the network, right? So only person who's got enough computing power, who's got trust in the network, okay, because it is not necessary that you will always be able to find this non-successfully. Someone else would be able to find it before you. In that case, whatever effort, whatever computing power you spend has gone waste. Okay, so you will only do it for two things. You want the incentive, that is the 12.5 bitcoins or whatever ethereums on the ethereum network that are mined to be paid to you, and you want to be part of the network. Okay, so only in those cases you will solve this. So you have shown intent, you have shown the proof of work for the network being a network member, right? That is why you get incentivized. So once this is done, the new blocks becomes available on the network. If you see, we are also calculating hash of the new block. So this hash now becomes header of the most recent block. So say Dave or anyone else on the network who's trying to put a new block, for him this hash becomes the previous hash. So this keeps on running every 10 minutes. Every 10 minutes, someone is able to solve it. Okay, and that block is pushed on the network. Now, if there were not enough people or not enough computing power available to solve this, okay, no transactions would go through on the Bitcoin network. So there have been instances in the recent past where people, there has been heavy traffic on the network, people trying to sell Bitcoin or transfer Bitcoins, but there are not enough miners available to solve the problem. Okay, so in that cases, normally the transaction should go through in 10 minutes, but transactions have been piled up for hours because there is no one available to solve these problems. So that is also an increasing or growing problem. For example, say me as a miner, right? I spend, say, computing power and electricity worth $10,000 each month trying to mine coins on the internet, on the Bitcoin blockchain. But each month I'm only able to mine, say, 2 coins. Okay, now 2 coins is worth, say, $14,000 today. Would I still want to continue, doing all this hassles and headaches for $4,000? Might make sense to me, might make not sense to someone else. If the reward is halved, so if I'm spending $14,000 in electricity and bandwidth and internet, and the reward I'm getting is just $10,000, would I continue to do it? No, right? This I'm talking about when I have the computing power. Now, suppose in the network there are people who've got supercomputers. I'm trying to mine using basic computers. I'll never be able to mine a coin, right? So all computing power and all electricity power that I'm spending is going waste because I'm not able to reap any benefit from the network. What will I do? I will just shut down my node and, or probably start mining for some other coin where the difficulty level is low. This is what is happening with Bitcoin. Earlier, people were able to mine using their personal laptops or personal, machines. Then they moved on to graphics card. Now it is very specialized machines. Still, individuals are not able to do it. So people have formed groups. Okay, they form a distributed network. They will all be connected to each other. They will combine their processing power and then mine these coins. Okay, so this is what a blockchain transaction look like. This is the site blockchain.info. If we have time, I will show it to you there, or you can yourself explore it. If you open the site, you will see something like this. If you see the relayed by column, these are pools. Okay, so ant pool is the name of a pool group. They would be like some hundreds or thousands of users who collectively use their processing power to generate this new block. So this height is the block, new block. So if you see, they are in sequential order: 520415416417141. So height is basically the distance from the genesis block. So from genesis block, if you map it in a tree structure, this is what 5,20,418 blocks away from the genesis block. Okay, the number of transactions in this block is just one, whereas in the previous block the number of transactions were 423, previous to that 790, previous to that 884. Total value sent just 12.5 BTC, total value sent somewhere around 12,643. This is size of the block. This is weight in terms of how much processing power was spent on that. Now if I click on one of these, okay, this screen shows up. So for example, I've clicked on this one, 520417. Okay, it will tell me the number of transactions in this particular block were 423. The output was 12.643 BTC. Estimated transaction volume, so all the transactions that were in that particular block was 308 BTCs. The transaction fees for this particular, for solving this particular block, was 0.09 bitcoins. Height, we've seen what height is. Timestamp is timestamp of the block, the received date, relayed by the mining information. This is the difficulty level. So if you can see, it is very, very difficult. The bits, size, weight, version. So this is version of the blockchain. We saw the nonce value, right? So this is the nonce that was used for calculating. So anyone who wants to verify whether it was really solved can simply use this nonce to verify. Reward of the block, so 12.5 BTC was reward. So like I said, currently every block when it is solved, 12.5 BTC are released. This 12.5 BTC would have been shared by everyone who is part of the ant pool, right? So divide this 12.5 with whatever this amount is, that will give you the number of people that are there in ant pool. So everyone got paid 0.09 BTCs. In terms of hash, this is hash of the current block. This is hash of the previous block. Merkle tree is the binary tree structure. So hashes of all the blocks are stored in a Merkle tree. Anything changed in data even by 1 bit, we saw in hashing, the Merkle tree would not match. So we would come to know that someone has tried to tamper with the transaction. Now this is for Bitcoin blockchain. Similarly, you have a site called etherscan.io, which lists similar information for the Ethereum network. So all of the fields are almost same. And this is the detailed version of one of them. Here you can see the name of the mining pools for Ethereum. So if you see Ethermine, it is one prominent mining pool which is solving most of the Ethereum nonce. In Ethereum, there's a concept called gas. Okay, so when you put the transaction for processing, you specify how much Ethereum you are willing to pay for your particular transaction to be prioritized, right? So instead of relying on a free miner to come and process your transaction whenever he feels like, you put a certain fees upfront, that if you confirm my transaction, this is the amount of fees that I am ready to pay. So you can yourself go through these two sites, etherscan.io and blockchain.info, and play around with the fields and see the transactions that are happening in live to get more information about it. Now, why all of this is important? Why is blockchain important? This is the Gartner hype cycle for emerging technologies. Gartner, they need no introduction, right? So each year Gartner produces this graph wherein they list the hype cycle for emerging technologies for this particular year. This is the map from the last year. If you see, blockchain is listed right here, where it is entering the trough of disillusionments. So whenever a new technology comes in, There is first the innovative trigger, then there is peak of inflated expectations, where everyone thinks this is going to solve everything, and then it enters the trough of disillusionment, where people start questioning whether it will really work, whether it is really the technology that it promised to be. Post that, some real use cases start emerging. So it is where virtual reality was last year. That is called as the slope of enlightenment. So if you see, blockchain is just entering the trough of disillusionment. Probably in a year or two, or maybe 2 to 5 years, it will enter this space wherein we would get real use cases of the blockchain. In 2016, blockchain was in the just entering the peak of inflated expectations. So if you remember, 2016 and 2017, that was the time when Bitcoin or any of these blockchain solutions raised the maximum amount of money. They were the most hyped, most talked about, startups, etc. If you realize, in 2018, that is slowly dying down. Okay, you don't see those many ICOs happening. Don't see those many people talking about it, because people have started questioning whether it can really deliver what it promised to. Going forward, I mean, somewhere around the 2020s, it should be that we should be able to see real use cases, the real potential of blockchain. So this is the right time. Obviously, if you want to learn the technology, this is the right time, because if it goes through this normal cycle, this technology will enter the slope of enlightenment and the plateau of productivity soon. So I talked about Don Tapscott some time ago. He says, in the trough of disillusionment, an emerging technology deals with implementation challenges. If you speak to people around you who are working in the blockchain space, you will realize that uh, people have started questioning now. Okay, there's a request from Sunil asking to be slow.
No, no, it was
Sunil,
long. It was long
yeah,
back,
I
not now.
I read it now. I read it now. So if I don't read the messages, you can say it on the mic, because I hide the chat to see the maximum screen. So were you able to get, or you want to repeat some part?
No, no, it's okay now.
Okay.
Yeah. Sunil, one quick question.
Yeah.
So the blockchain example that you were showing, so if I see the height of 1, so that would be the coin that Satoshi would have created, right?
Exactly. So that is a Genesis block.
I see. Okay.
Okay. So the height here is 520417. If you go back tracking it using the previous hash, when you reach the first block, you would be able to see the message that I showed yesterday. Chancellor on brink of payout for banks, something of that sort, right? That is the message that was part of the first block.
Okay.
Okay. I think we have. I mean, is it okay if we continue for some time, or you want to continue in the next session?
No, no, please continue.
No, we can
Okay.
continue.
I'm okay.
Okay. So we are starting with new topic, wherein in your projects, how do you decide whether you use a blockchain or whether you use a database? Okay. Before that, we will see these 3 pages wherein it lists the key vocabulary. I will quickly go through it, because most of it I've been talking about and you would know. So cryptocurrency, I don't think it needs introduction. We all know it as digital currency based on mathematics, uses encryption techniques, and there is verification of the transfer of funds. And it can operate independently of central banks. The NKS missing. Typo, I will correct it. Consensus is the process through which all the people in the network agree and maintain the distributed ledger, and they arrive at consensus on the ledger's contents. Confirmation means that the blockchain transaction has been verified in the network. It means that someone has performed the proof of work on the transactions, and the transaction is confirmed now. Chain linking is basically, we saw the previous hash next hash concept, right? So that is how you link all the blocks. Block rewards are rewards that are paid to miners for them successfully solving and calculating the nonce and confirming the transaction. Block height we saw just now. ASIC refers to a specific group of hardware, which is application specific integrated circuit. Like I said, mining Bitcoin is not possible using normal computers and normal hardware now. That is why you require ASIC miners. There is a miner called Ant Miner, which a lot of people use. Earlier, people were using GeForce 1080 cards, the graphics card that we have on our computers. So obviously, GPUs are dedicated units, right, for specific functions. So some time ago, even GPUs were used for mining. The Any modern day laptop would have the same card, GeForce 1080. So if your laptop has that, okay, and you have spare capacity, obviously you cannot mine Bitcoin, but you can try mining Litecoins or Monero or similar coins. Altcoins is used to refer to any other coin that is an alternative to Bitcoin. So apart from Bitcoin, all of the coins are referred as altcoins. Most prominent altcoin is Litecoin. Initial coin offering. So like you have IPOs for offering shares before a company is listed. Similarly, you have ICOs wherein companies who are trying to raise funds will sell their coins for a specific amount in terms of dollars. So it is like you fund the company in its initial days and you receive coins before the coins become available on the network. So sort of IPO. Hash rate is the number of hashes that can be performed by the Bitcoin miner in a given period of time. So we saw that calculation of nonce and generating new hash, right? When you buy mining hardware, you measure the performance of it in terms of hash rates. So like you measure the performance of your processor in terms of gigahertz, hash rate is the measure for your hashing or your mining devices. Having Bitcoin has finite supply. So like I said, every 4 years, the generation of Bitcoins is reduced by 50%. That is called as halving. And that is how we have arrived at the figure that in year 2140, uh, no more Bitcoins would be generated. Gas is a measurement equivalent to the computational steps for Ethereum. So like I said some time ago, gas is the amount of Ethereum that you are willing to pay for a miner to confirm your transaction. Fiat currency is the normal currency, the physical currency that our governments print. Digital identity is your online identity. Ether is a native token in Ethereum. DAO, an important concept. So DAO is basically decentralized autonomous organization. Now in a company, normally it would be a private limited company or a private limited company, public limited or private limited company. So the company has directors, the company has stakeholders. In case of DAO, a company exists where there are no stakeholders, okay? Anyone like us could join, become part of that decentralized autonomous organization by purchasing its coins or purchasing stake in it through its coins, and you are running that company, right? So all of the rules are in set in the blockchain of that particular DAO. No one needs to make decisions. So it is like smart contracts are already coded as part of that DAO. Similarly, there is something called as DApp, which is called as decentralized application. It is completely open source, operates autonomously, no entity controlling the majority of its tokens. So on Ethereum blockchain, you are able to create DApps, any app that you want. It is like an ecosystem, like Play Store or the Apple Store. You are able to create your apps, place it there. Anyone who becomes part of that, the rules automatically apply to them. So pre-coded contracts. Satoshi is the smallest unit of BTC. So it is like 100 millionth of a single Bitcoin. That is the level of, the lowest level till which you can divide the Bitcoin. Okay, like you have, a dollar, $100, cents, etc. So this is the smallest denomination for a Bitcoin. Digital wallet, we all know. Transaction fees, we all know. Transaction block is collection of transactions. So we've seen that how a transaction is placed. Token is digital identity. So basically coins. Coins are also called as tokens. Smart contracts, we know. Proof of work. So I said there are three kind of algorithms, right? Proof of work, proof of stake, proof of authority. Proof of work is used on Bitcoin blockchain. Proof of stake is used in Ethereum and few other. Some algorithm, some implementations tweak them so they reduce the difficulty. Private blockchains or permission blockchains use proof of authority. So in proof of authority, there are nodes, designated nodes, who are identified that only these nodes can confirm transactions, right? So they have authority to uh, arrive at the consensus. So whenever a new transaction is placed on the network, these nodes will pick it up, confirm the transaction, push it on the network. So Ripple sort of uses this, wherein they've got banks which transfer money using the Ripple coin XRP. So these designated nodes from the bank, these are the bank servers. They act as the consensus making party. That algorithm is called as proof of authority. Private key, we all know. Node is any computer that connects on the blockchain network. Similarly, there's something called as full node. So node can be anyone. A full node is someone who has to download the entire uh, transaction history till now, and they become full node. So they are able to add to the transactions. Okay, so this is a huge list. I've tried to cover almost most of it, but obviously there are more words that are used. There are a lot of jargons in the blockchain world, but knowing this, you should be good to go. You should be able to hold a conversation with anyone in the blockchain space. Database versus blockchain. So database, all of us know what a database is. A relational database, it is a row versus column thing. You've got primary keys, you've got sequence records, right? So database is always in a client server architecture. The database admin will decide who has what rights, who can create new records, who can update records, who can read records, who can delete. So the CRUD rights, create, update, read, delete, right? In database, data can be easily modified or deleted. Distributed database is suitable for an organization where all users trust each other and do not want to keep duplicate record of the same data. Blockchain, however, comes into play when the entities cannot trust each other. So the entire point of blockchain is we do not need a central intermediary, or we do not need people to trust each other. The trust is in the network itself. Again, in a database, an intermediary maintains a private database of records. In a competitive marketplace, you do not want to share information with each other. You want the information to remain confidential. So businesses, like banks, will prefer privacy of a centralized database than blockchain that is
Hello. Hello.
Hello, Sunil. We are not able to hear you.
no single party who can control the information and control who views what, right? So it combines the power of internet and cryptography to cater information to everyone. Like I've been saying repeatedly, modifying or deleting data is not possible in the blockchain. In fact, the unalterable data entries is the, most important aspect of this distributed ledger. Blockchain has only right, data structure. In blockchain, transactions are verified by consensus from one node on the blockchain. Each one has a record of all transactions. So anyone on who is a full node will have record of all the transactions. But it may not be suitable for businesses which prioritize confidentiality. So if I am Coca-Cola, I don't want to share my trade secrets with anyone on the internet. I would not want a blockchain implementation for storage of my data, correct? So depending on the type of implementation for your project, you should decide whether you want to stay in a database or you want to stay on the blockchain. The technological benefits may be there in blockchain, but if you want confidentiality, you may want to go with distributed database or a centralized database, relational database
Yes,
at your workplace.
Sunil, your voice was broken for a few minutes, so might be we have missed. So could you give some examples where we can use blockchain other than this cryptocurrency?
Yes, we will. So there are a couple of slides on this. Uh,
Yeah,
Let me finish that and we'll come to that.
yes, Sunil.
Okay.
Uh, I have one question. So you were saying that blockchain is not suitable for confidentiality, but using public key, private key, I think
No,
it
no,
is
no,
fully
no.
confidential.
Confidentiality, yes, but I don't even want someone to know that I'm doing transactions.
But I don't know who you are, right?
Uh, sh- you don't know. It is pseudo anonymous, like we saw some time ago. If I'm doing transaction with a merchant, you are hellbent on trying to find out who I am. I list my address with the merchant to ship the goods. You are able to find my address. You are able to match or link my virtual address with my physical address. Any transaction that I am doing further with that particular virtual address, you know that it is me, right? So if you want to remain 100% confidential, maintain 100% confidentiality, the best way is to switch off your computer, throw your mobile phone, go in a cave. If you are there on the internet, someone will be able to trace you somehow, like how they trace Satoshi or how they claim to have traced him.
Yeah,
So
one thing which I can think of is like this confidentiality purpose is like if I am a manufacturer, if I sell something and I don't want the other competitor to know who are my customers.
exactly. So for
So I
banks,
don't want to put, yeah.
yes. So banks, even though they are pushing, I mean, they are trying blockchain, they don't want to share the details of their customers, right? They don't want the other bank to know that this customer has, got a lot of balance, because if Citibank knows that, there is one customer of Merrill Lynch, who's got say 100 million in his account, they will obviously try to eat away into Citibank's customers, right? They will give him better offers. They will try to make, sell him new products. So if it is the kind of data that I do not wish to share with anyone, even though blockchain may be, offering whatever level of security, I don't want to take any risk. I mean, there's nothing wrong in storing it in the database, right? Blockchain may be offering a lot of technological solutions. Do I really need it for my particular application? No, I'm still better off with staying in a relational database. So in that case, I mean, it doesn't make sense to migrate to a blockchain based solution. If I'm able to control what data only, I mean, this data, even if someone find out, I don't have a problem. In that case, yes, I might well store it on the blockchain.
No, so the biggest use case of blockchain, which is cryptocurrency, is like where that like in every financial transaction, the confidentially is a key. But in
when
that also,
when you are sharing cryptocurrency, correct?
uh,
Yes, but are banks sharing cryptocurrency?
no,
No, banks have to share physical currency. For physical currency, that has to come from someone's account. For
right.
that to come from someone's account, that person has to be identified. Banks maintain all that information. When you are making payment to a person in the another country, there are certain laws that apply, right? Anti-money laundering and terrorist financing, these kind of laws. So the other country needs to know which particular person initiated this transaction. So all of that information has to be made available to the other regulator sitting in that country. So the information has to go in a non-encrypted format. If the information is going in a non-encrypted format, it is available for everyone to see, unless the bank in this country and the regulator in the other country decide that we too will share this information on a blockchain in an encrypted format using this particular key. Do you think the regulator and the bank want to spend that kind of money building a new system when there is no problem in the existing system?
No.
Yeah, so Vinay can, I think very simple example will be, suppose a person, Bob, has $1 million, and right now bank is putting that $1 million he had in the bank account in a relational database. But if they are using this blockchain technology, they need to put that Bob name, address, and that $1 million in the blockchain. Now, if he's transferring from Citibank to, suppose, Bank of America, so both Bank of America and Citibank can see that this guy Bob with this physical address name has this $1 million sitting in the Citibank. So he can, like, Bank of America will try to chase him, like as Sunil was explaining. So they don't. It's not in the interest of this bank to expose that kind of information on the blockchain, right?
Yeah, though that's what my question is, Sharad, because nobody knows who Bob is, because we are talking in public and private key, right?
No. So it will not be in the public and private key, because when you are sharing this information, then probably they will know who they need to expose who the Bob is.
Yes, the message will be encrypted using that. Okay, but you send that information to the other bank, they can decrypt the message using your private key. You are sending that information for them to read, right? Today, do banks share this information with each other?
No.
Right? So is there a use case for them? If they're not doing it today, do they really need to do it on the blockchain?
No.
So if there is no use case for them, why do they need to get on the blockchain?
Right. Yeah, got it.
So there has to be a use case. There has to be a benefit for both the parties to get on the blockchain.
No, I got it now. Got it.
Yeah.
Thank you, Sharad, and thank you, Sunil, for explaining. Thank you.
It's good to have others participate. Yeah. So next point is integrity and transparency. Integrity: every user can be sure that the data that they're retrieving is uncorrupted and unaltered since the moment it was created. Transparency: every user can verify how the blockchain has been appended over the time. So how do you make a choice? On the next slide, I will show a nice picture how you can decide whether you should stay on a blockchain on a or a distribute or a normal database. So the right choice out of the two would depend on your business use case and your preferences. If you want to do something within your network with your data, with the computers that you control, then database is the obvious choice. You don't want, like yesterday there was a question that what happens if the internet fails, right? So it is a distributed ledger. You are relying on everyone. Tomorrow, if 50% of the network switches off their computer, or there is a massive earthquake in India and all of your nodes were in India, right? The entire database is wiped off. So do you want to take that risk? No. In case of banks, you want to have it controlled. You want to have the data at multiple places. You are still better off with normal database, right? But if you want, if you have a use case where you don't want to pay for the entire cost, you want the network to share the cost, like for Wikipedia, right? Would it make sense for Wikipedia to go on the blockchain? Yes, it would. Instead of sharing the entire cost of server, having the entire cost of servers at their end, they might as well, put it on the blockchain and let everyone on the network participate it, share the costs, right? So if you don't want to modify past data, want to have it immutable, want it to be publicly accessible, blockchain is a better choice. So this is the diagram that I was talking about. How do you decide whether you should use a blockchain? Sorry, someone is speaking in the background. Can you go on mute, please?
Sunil, do you have a right to mute everyone? I think you should.
No, I can't see that option. I can't see that option.
I think someone did in the beginning of the call. I think probably Sridhar.
I think Ashok or Sridhar has that.
But you should be like teacher. You should do that.
I am only seeing option to mute myself, which obviously I don't want to do.
No, please.
Can you check that attendees tab on the GoToMeeting? If you expand that.
Yeah, I am on the attendees tab. but I don't see an
Yeah.
option to mute
At the
everyone.
bottom, do you see all mic which is red and all mic which is green? Just at the
I can only see that Ashok has been muted by the organizer and no one else.
at the bottom, do you see a band right above chat,
No,
like
I mean
invite?
there's no option to unmute.
Yeah, maybe you are the presenter. Let me make you the organizer also.
Yeah, so that Sunil can mute everyone. I would like him to have that power so that he can mute when he's speaking.
Yeah, can you see now, Sunil? Do you see any difference in the attendees tab at the bottom? Do you see mute all, unmute all, invite?
No.
Okay.
Okay, figure out later, no
We'll
problem.
figure
I
it out.
don't
Yeah.
know.
Yeah. Okay. So how do you decide that? Does my use case involve a database? No, I should not be using a blockchain. Yes. So will there be numerous users updating my database? Yes. Then I go for a blockchain. No. Then I should be using a centralized database. Now, do these users need to trust each other? If they don't, then I should utilize multiple copies of a centralized database. If the users need to trust each other, then are there problems caused by the use of a central third party? No, then use a third
One
party
second,
intermediary.
Sunil.
Yes,
1 second. In this block, you said that does the user need to trust each other, and if
correct.
they don't trust each other, then in the
Then
no case
you
also, I think we can use this blockchain, right? So there are
no
two
so
types of blockchain you mentioned:
no
public versus private, right?
no one is stopping you from using it right at the first step itself, right?
Mm-hmm,
Even
mm-hmm,
it does not involve a database, I still go ahead and create a blockchain. No one is stopping you. So this is
mm-hmm.
talking about the best practice. Okay.
Recommended.
Okay,
Yeah,
okay.
recommended. But no one is
Mm-hmm.
stopping you. Even if you use a blockchain in case you don't have a database requirement, you could still go ahead and deploy the platform. No one is stopping you from doing that.
Okay.
Okay. So are there problems caused by the use of central third party? No. If it is no, then use a third party like we've been doing in case of government agencies or banks or central banks, etc. If there are problems, then do transactions depend on the or interact with each other? If no, then use the master slave database. If they interact with each other, then you should be using blockchain. Now, most of the implementations, and there was a stat somewhere I read that there were 26,000 startups in the last year on blockchain, and 92% of them are dead by now because everyone wanted to do something on the blockchain, but they're not looking at the real use case. So you have a problem. The first choice is go and create something in blockchain. But if it is not required, your solution will not sell and your startup will die. So this is a nice handy list to decide whether you should be doing something on the blockchain or not.
So in this slide, Sunil, I have now one doubt, and
Yes.
you have to clear that. So if you look at Bitcoin, right? In the Bitcoin, how do transaction depend or interact with each other?
You have the previous hash and next hash.
No, but if
You
say
have
I am transferring, say, from my Bitcoin from me to say Sharad, so Sunil has no interest in that, right? It is Sunil
Sunil
like.
has no interest, that is right. But
Mhm.
the block in which your transaction would be placed, okay, depends on the previous block, and the next block that would be generated, you are generating the hash for it. So
Oh,
the
okay.
transactions are dependent on each other.
Oh, like that doubly linked list that we talked about.
Yes,
Yeah,
correct.
yeah, right.
Okay, distributed ledger, we've already spoken a lot about it. So if you see this particular diagram, this is how the current payment systems or any system where you've got a central party works, right? Everyone sends their transactions to the central authority. The central authority does all of the reconciliations and it will send the response back to them. In case of a distributed ledger, all the parties talk to everyone. Okay, so they will do all the transactions. Their ledger will be shared with each other. Okay, there is no central copy of the ledger. in this particular case, if I had to see what is the current status for user A, what is his current balance, I could come and look at the central ledger, okay, instead of having to look at these 4 ledgers. Here everyone has got their individual copies and they keep sharing it with each other. So that is what a distributed ledger is. It is a type of database that is spread across multiple sites, countries, or institutions. The records are stored one after the other in continuous ledger. Distributed ledger data can either be permissioned or unpermissioned, right? And all information is obviously secure on it, kept securely and accurately using cryptography, and can be accessed using the public keys and the private keys that we saw earlier. This mechanism makes sure that everyone has the most recent copy of the data always, and the records are resistant to malicious change by any single party. So even if this party makes change, I mean, he's a malicious, party, he makes change to the database, the rest of the 3 copies we know that has not changed. And because this is more than half of the network, this forms the truth network, and this copy will be termed fake, and the transaction will not go through.
Right.
In the blockchain ecosystem, we have 4 most important stakeholders. So any ecosystem is a sum of its stakeholders, right? They drive where the platform is going to go. So we have users, we have investors, we have miners, and we have developers. It is very important to understand all of these 4 roles. So investors are currently the majority of stakeholders in all blockchain systems currently, and that is the reason why you would see a huge volatility in terms of the prices of the coins being traded. So like I said some time ago, it is very common to see a coin going 10x in a month, or a coin losing half its market value in a day or in a week, because these investors have put huge amount of money. There are certain slangs in blockchain world for investors, so they are called as whales, right? A whale signifies a huge mammal, right? So these are people who've put huge amount of money in blockchain. Okay, so they can drive prices like anything. So if I want to pump the price of say Bitcoin, I will start purchasing, and the Bitcoin is trading at 7,500. I will start purchasing it at much higher prices. So automatically the market price for that coin goes up. So I will drive it to a point where it becomes too high, and then I will at that instant sell all of my coins. So for example, I'm able to drive it from 7,000 to 9,000, and at that point I've got say 50,000 coins. I sell out all of it and I cash out. Now because there has been a lot of coins available for sale, the price will drop. So retail investors like us, who bought in the hype, will be left with coins purchased at high prices which no one is willing to buy. So these whales, these people referred as whales, are able to drive the market. Okay, like in stock exchanges, if someone was able to, if someone was trying to do that, you have upper circuit or lower circuit. Below, after that point, that stock cannot be traded for the day. Okay, because there's a central authority trying to see that no one is able to manipulate the prices. But that check is not there in the blockchain ecosystem. No one is monitoring it. That is why it is a very risky proposition to trade blindly in these coins. Next you have miners. So miners are the guys who do all of the hard work, who prepare the block, who verify the transactions and put it on the blockchain. So in order for a blockchain to function and maintain its integrity, it needs large number of independent nodes. These nodes are nothing but the miners. The people who own these computers are called as miners. Since the integrity of the blockchain is directly related to the number of independent nodes on the network, there also needs to be some incentive to mining. People are not going to do mining for free. It is not charity. They are spending huge computing power, huge electricity bills for these, so they would need some incentives. So like in blockchain, in the Bitcoin blockchain, if they are able to solve a particular block, they get 12.5 Bitcoins. Similarly in Ethereum, they get paid in gas, right? So there has to be an incentive and there has to be a consensus algorithm. If I solve something using my computing power and my bandwidth and my electricity, there should be a set rule that if I'm able to generate the nonce, or if I'm able to generate the required hash, everyone has to agree. It should not be that, I've spent all the effort, done the right work, and then there are two people with more processing power who say, no, we are not going to accept your transaction. Instead, there's another friend of mine who solved it, and we are going to offer him the reward. So there has to be a set consensus algorithm, which is agreed by everyone in the network. Mining a single block is...
Yeah, sorry,
go on.
Sunil.
Yes.
So if there are multiple people who are mining the same block,
correct.
There are like 10,000 people who are mining the same block. So whoever mines the first, they will get the reward. Other people will not get anything, right?
Exactly.
So it works like that?
Exactly. So that is why what people are doing now, okay, they know that individually they will never be able to solve it. Okay. So let 100 or 1,000 of us come together, connect our PCs in such a way that it becomes a giant supercomputer, and we collectively solve it. And if we are able to solve it, we share the reward.
Okay.
Okay. So that is the
next line that there will be group of people. Suppose even if these 1,000 people come together, there are other groups come together. So
exactly.
Even
that
in that,
is happening.
There will be one
yes.
group will win, other group will not get
yes.
anything, right? So
exactly.
whatever computation, whatever power they did, everything gets wasted for them, right?
Wasted, right. That is why it becomes difficult for individuals to keep mining, because they will never be able to mine anything, and that is a wastage of resources from their side. So they will stop mining.
So does
when we
this
saw the
algorithm doesn't support that if the one group page started mining, it will ask the other group to wait and start?
No.
Okay.
No.
Okay. Mm-hmm.
So it is who solves this first.
Okay.
Right?
Okay. Got it.
And like we saw on the blockchain screenshot, just let me complete this and then you can ask your question.
Sure.
Like we saw on that screenshot from blockchain.info, you could have seen there were names of people who solved it, right? So the names were like Ant Pool or Ethereum Pool, right? So these are name of the pool. So people have come together and formed these pools. Yes, there was a question.
Yeah. So I have heard in like China there are a lot of data centers dedicated for these mining activities.
Yes.
So
that is a pool.
Okay, that is a pool.
You can also join a pool by not even having a hardware. So there are cloud hardwares available where you go and purchase their spare processing capacity. They will do mining on your behalf. If the particular pool that you belong is able to mine a block, then you get rewarded for it. But again, same thing, if they're not able to mine the block, you have to pay for the processing capacity. So hashflare.io is one such website that gives you processing power and enrolls you to a pool. If your pool is able to solve it, you get the Bitcoin, the equivalent Bitcoin for your pool. If they're not able to solve it, you have to still pay for the processing power that you took.
Okay. So this is like one of my fundamental confusion, and that I got always stuck with. So when I say my physical currency, where we talked about some gold in some World Bank, so can I say that in cryptocurrency it is this processing power which is like kind of value that it, because every currency what brings
exactly. So that is your proof of work, right? The processing power that you're spending is your proof of work, is your intent, is your effort that you have spent trying to solve that problem. That is why you are getting rewarded. So the amount of work that gets done, that releases a new cryptocurrency in the market. I'm not a cryptocurrency, a crypto coin in the market, like Bitcoin, right, or Ethereum.
Yeah.
Okay, then you've got developers, obviously.
But like gold has some value to others, but what is this processing? I fail to understand what are the, like suppose I have a laptop, very big laptop, and which I would be able to mine in a year, whatever, like suppose what supercomputers can do in a day.
Correct.
So what exactly my laptop is going to do? That is what I fail to understand.
So we saw that process where you have to generate the nonce and you have to generate the hash.
Okay.
That is what your computer is doing. For your computer to able to guess or find, okay, the
Mm-hmm.
right hash and the right nonce, you get
Mm-hmm.
rewarded in bitcoins. Okay. Now there are a lot of people who are doing the same thing. You got that bitcoin, they did not, right? For
Yeah.
them, they think that bitcoin is currently valued at $7,500. Okay.
Mm-hmm.
If you go to sell it, you might be able to sell it at say 7450. Now the
Okay.
processing power that you spent, okay, may not have been equal to 7450. You may have spent say $5,000 trying to mine that block, considering there were failed attempts also, right? So you made
Right.
a profit of 2,500 on that
Mm-hmm.
particular transaction. So that is what people are trying.
Hmm. Okay. Got it. Got it.
Okay.
Thank you. Thank you.
Yeah. No. So there are two types of developers in the blockchain world: blockchain developers and DApp developers. Blockchain developers are the people who develop the platforms. You deploy the platforms, add to it, build the applications on top of it. DApp developers build a decentralized application that can run on the blockchain, right? Thus providing users with a reason to use the blockchain. So the platform are built by the blockchain developers, and DApp developers build applications on top of it. Users are normal people like us who use the blockchain or the cryptocurrency to achieve some purpose other than just trying to buy and sell cryptocurrencies. So for users to exist, a cryptocurrency have to have some utility, like XRP, Ripple. Basically, the utility is that you will be able to send money from one country to another. Correct. So that is the utility of that particular coin. Uh, Before we start with the blockchain ecosystem, this is just to put the entire crypto space in perspective. So all of the money in the world is equivalent to US dollars 83.6 trillion. All of the money in US is 83.6 trillion. The stock markets are worth 66.8 trillion. Physical money in circulation is 31 trillion. The gold market cap is 8.2 trillion. Similarly, Apple is valued at 730 billion, Amazon at 402 billion. All cryptocurrencies combined is just 100 billion, of which Bitcoin alone is 41 billion. So you can see how small this market is as of now in comparison to what we already have. Larry Page, Google's founder, is almost equivalent to the entire Bitcoin. Bill Gates is almost twice that size. Okay, so blockchain structure. Blockchain consists of three core parts. Block, so list of transactions recorded into the ledger over that 10-minute or whatever period, like for Ethereum 14 seconds. Size, period, and triggering event for blocks is different for every blockchain. Not all blockchains are recording and securing a record of movement for their cryptocurrency, because depending on the type of blockchain and your particular application, you would not be using it for that specific purpose. In that case, it does not matter that you have to confirm transactions every 10 minutes. You could do it at end of day, you could be doing it every minute. Depends on what your use case is. Chain, basically the same hash concept. So that is how the linked list works. That is how you are able to traverse back in the history right till the genesis block. That is how if you want to investigate a transaction, who started this transaction, what happened to the money, where is that particular Bitcoin now, you can traverse forward in that direction from that point. So the chain ties the entire ecosystem together. It is like the second line reads, it is a magic glue that holds the blockchains together and allows them to create a mathematical trust. The last is the network. So network is composed of full nodes. As I said, node can be anyone who joins the network, but for you to become a full node, you have to download all the transactions that have taken place till now in the network. So once you download all the transactions that have taken place, you become a full participating node. You can start mining transactions. You can start adding new transactions to the network. Okay. Nodes are located all over the world and can be operated by anyone. It is difficult, expensive, and time consuming to operate as a full node. So people don't do it for free. That is why they are paid
certain fees for doing your transactions in terms of gas for Ethereum or in terms of Bitcoin rewards. They are incentivized basically to operate the node, and the underlying Bitcoin algorithms reward them for their service. So the reward is usually token or cryptocurrency like Bitcoin. We come to the last point for the day, which is permission versus permissionless. So permission blockchains provide highly verifiable data sets because consensus process creates digital signature. So permission is where you control, which is where most of the financial institutions are playing with. They will create a blockchain. They will have a distributed ledger where they will be sharing limited information within departments or within with intra banks, but the nodes which can confirm transactions will be pre-decided. These nodes will be the bank servers. They will decide who has what access. They will decide who can add transaction to the network. So not everyone who's on the network will be able to add transactions. Not everyone will be able to read all of the information. So they decide all that. So that is called as a permission blockchain. And all of these blockchains that we talked about till now, Ripple, uh, Bitcoin, Ethereum, etc., these are not permission blockchains or not fully permission blockchains. They are mostly public blockchains. So most of the enterprise blockchains like Hyperledger and Hyperledger from IBM, or specifically that in-house built blockchains, they are called, these enterprise blockchains are based on the permissioned uh, funda. So what it offers is privacy. Using a permission blockchain, it allows only actors who have rights to view the transaction, who can add to, who can uh, view. So banks are trying to form a consortium where they will have dedicated nodes. Each of the bank will have, say, one computer dedicated, one server dedicated to add transactions. Only these nodes will be able to talk between each other, and it will also be defined as to what fields they can view. Scalability, it uses a simplified proof of stake. So proof of stake is where, for example, when you started the blockchain, you decided that it can have 1 million coins, right? So it was a consortium of 10 banks. One of the bank owns, say, 50% of the stake, right? So it would have, of the 1 million, it would have 500K, correct? So it is that particular uh, bank server which would get 50% of the problems to solve. So the mining reward or the fees reward would be shared 50% by this particular bank because their stake is 50%. So that is their proof of stake. The more stake that you have, the more transaction fees that you will be generated, getting paid. Fine-grained access control. So in a permission blockchain, it allows you to restrict access to the data within the ledger. R3CEV is one such consortium where most of the large banks, Citi, HSBC, uh, and I forgot a couple of other names, JP Morgan, all of these banks are part of R3CEV Corda. So this is a consortium where all of these banks are trying to share information with each other, and it is restricted access. Permissionless blockchain. So the Bitcoin blockchain or the Ethereum blockchain where there is no one single owner, and it is so large that it cannot be owned. The purpose of unpermissioned ledger is to allow anyone to contribute to the data to the ledger, and everyone is in possession of the ledger. So today you decide you want to become part of the Bitcoin blockchain, you can go ahead, download the entire data that is available right from the Genesis block, and you could start mining new blocks. No one is stopping you from that. In a permission blockchain, you cannot do that. In a permissionless world, you do not have to prove your identity to the ledger. In a permissioned blockchain, obviously the bank would know which server is who owns that particular server. So your identity would be known in the permission blockchain. As long as you are willing to commit processing power to be part of network and extending the blockchain, you are allowed to join a permissionless blockchain and be part of it. Any miner who is playing the game by the rules may be able to solve the hash puzzle and verify the block of transactions and win the mining reward. So higher the mining power, better are the chances of winning the mining reward. Conclusion, one critical difference between the two is the underlying mining model. Permission blockchains use proof of work. So in proof of work, as long as 51% of the nodes are honest players, Sybil attack will not happen. Sybil attack will not happen. Network consensus will be reached. Everything is good. In permissioned blockchain, that level of difficulty is not required, right? You don't need that much complexity, because you know the nodes who will be adding transactions, you know the nodes who is who, and you can always catch hold of them for transactions that they have added. So that is why you use proof of stake. So they use specific algorithm that is called as Raft or Paxos or other PBFT algorithms to reach consensus instead of proof of work. So that's about permission versus permissionless. That's it for the day. If you've got any queries on what we covered.
So just one more thing, Sunil. For
Yes.
both day, yesterday and today, can you send us this documents
PPT?
also?
Yes,
Yeah.
yes. I will share it with Ashok, and he will email it to him.
Yeah. Okay. Perfect.
Okay. Any more questions, or we can wind up?
So I have something to discuss with Vinay and Sunil and Sharad. I think these guys were talking about Python machine learning. So this is not related to blockchain. So I would let this session conclude before I start that discussion.
Yeah, I mean, we can conclude for today. I mean, I have nothing. Thank you very much, Sunil, for your time and patience, man. You are.
Thank you.
All right.
Okay, thanks everyone. Yeah.
Hey Vinay, I think
Yes, Sridhar.
you were interested in the machine learning offering that we have, right? Or was it Sunil? Both.
Yeah, that's right, Sridhar.
So I sent you the details of the curriculum of what we are doing.
Yeah, I saw that. Yesterday I saw that.
Yeah, so we were having a discussion here, and we can do the same thing as you did, like a demo session. If you want to have a kind of a demo session of learning, the first session is on May 18th, which is a Friday.
I see.
So the machine learning batch is from your time. It will be Friday evening and Saturday evening.
Yeah, I saw it. It is 7:30 to 9, I believe.
Yes.
Our PhD.
Yes.
Yeah.
So let us know if you're interested to join that Friday session as a demo session and see what it is before taking a call. We'll be more than happy to arrange it.
Sure. Thank you, Sridhar, for that and sending me that information. I'm definitely interested in that. I'll definitely try to make a point to come on that 18th. And I'm assuming most of the participants there would be from India, because I assume would be Saturday and Sunday morning there, right?
Yes, you're right.
I see. No problem. I don't have any problem with that.
Okay.
No, yeah. Thank you very much, Sridhar, for sending me that information.
Hey, no problem. I hope you guys are, the training speed and everything is correct and content is correct. If at any point you have any feedback, just reach out to us. We are here to tweak and personalize this training for you guys.
No, I think the training is really good. Yeah. So speed and everything. At least personally for me, it's good.
Awesome. All right, guys.
Yes, I like it. I mean, the way he is very patient, actually, Sunil. I know. I mean, we asked too many questions, but I think this is for the first time I'm going through this kind of an train. I have attended a lot of WebEx meetings, but this is kind of training I'm attending for the first time. So it is good that we discuss with each other. Like Sharad sometimes clarifies my doubt, and it is good. I mean, I'm enjoying it so far.
Yeah, it's actually just like a classroom, and it's like more convenient than a classroom. You can be at your home, have coffee, attend to a few things in the middle, and still be present. So we have had pretty good feedback, for our session.
Yeah.
And
Yeah.
Sunil is a pretty well researched person in this topic. He teaches in big banks and stuff. So you guys have a pretty good guy, and you can check other people who are doing this course. Our course is very comprehensive and very competitive.
I see. Sure, I'm definitely going to recommend in my network.
That'll be very helpful. At the end of the session or sometime during the session, I think Ashok might reach out to you guys for some sort of a recommendation or testimonial, and we would need your permission to put those testimonial on our site. So that'll be highly appreciated if you guys can do that, if you liked it, of course.
Yeah, sure.
Okay, guys, thanks for your time. Have a wonderful rest of the day.
Thank you very much,
Shridhar. Bye.
Yeah, bye.